she's saying to start. She's saying we can start. Okay. All right. Check. Can you hear me? Okay. On Zoom, are you able to hear me on Zoom? Okay. Good morning and welcome to day 2 of the second Mobility Summit. I trust that you've all had a great time of learning yesterday. And today, what can you expect? You can expect a double portion of panels, experts, and discussions to engage and enthrall you. So without much ado, I call Dr. Ramki, CEO MInT, to come and brief us on a recap of yesterday and also let us know the agenda for the day.
Wonderful. Good morning, everybody. Welcome to day 2 of the MInT Mobility Summit, the second MInT Mobility Summit, where our theme is exploring the use of AI in mobility. So yesterday, in terms of recap, was an exciting inaugural address by Sri Krishnan IAS. From MIT, right? As my Secretary of the Ministry of Electronics and Information Technology, where he talked about digital India and the digital transformation of the country, right? And the role of building out the India stack, starting from UPI, Aadhaar, all the way to now what we are talking about in terms of the mobility stack, right? So that was very inspiring to kind of listen to the passion with which the government is interested in transforming the country. And MInT has a very important role to play in that transformation. And we are going to be front and center as we enable that kind of transformation in the mobility space. So we heard that yesterday, followed by a very inspiring address by our guest of honor, Dr. Shivkumar Kalyanaraman, who heads the NRF. And the NRF, for people who may not heard them, and for the people who are joining us new today, is the National Research Foundation. Not only they have a mission, they also have the money, right? The government of India has been, from what I hear, allocating more than 1 lakh crore of rupees every year to foster research. And this is about foundational research with a mission to kind of bring that research kind of ethos into the country, right? And he talked about the use of that type of capability in understanding how to make mobility better for the country. And we have opportunities for collaborating, coming up with ideas on how, not only just as an academic institution here at IIT, but more importantly as MInT Collaborative, where we are bringing the industry, the academia, and the government together in terms of putting together programs and research kind of initiatives to help with that transformation. And also, we had a wonderful session with our founding members from the industry on the memories, right? We went down the memory lane for what happened in the last year. We kind of reminisced from being nothing but a few words on a piece of paper to actually having formed this collaborative here at IIT Madras, and what we have accomplished in year 1. And the founding members shared their own memories, but also they shared about what their expectations and their aspirations as we go forward. And it was interesting to kind of see a couple of themes emerge, right? One is safety, and the second is about efficiency and sustainability. The pillars in which the MInT is founded, right? How do we make mobility safe for everyone, whether it's preventing accidents on the highway or protecting a pedestrian when they're crossing the road. So how do we look at that part of it? And how are we going to use artificial intelligence, the theme of this year's summit, to enable those types of activities? So they want to see the stack actually in action by the end of year 2. So we have a big challenge ahead of us in terms of building concrete, building more, right, to kind of get this ball rolling in terms of what MInT has been set out as a mission to do, right? So we heard those aspirations. And finally, we had a wonderful tete-a-tete, a one-on-one between Professor Parthasarathy from Ohio State University and Professor Keller from Technical University from Dresden on what is AI and what does AI mean for mobility. And there was a caution, right? While AI can mean a lot of things and do a lot of things, but we just have to be careful in terms of using the technology. AI probably makes things happen faster, can solve problems, but it is still not fully tested. Whether it is a language model where we are giving an instruction to the car in terms of how it should move, or in terms of actually predicting the interaction between a vehicle and the road, right? The decision-making capabilities of AI is very much at its infancy. So how do we be cautious about using the technology as we move forward? But it was very interesting to see how much has changed. And I still remember the one concept that they talked about, where they had autopilots using mechanical devices, which is also intelligence, using gyroscopes, starting from the 1920s, right? So when aircraft were on autopilot, that was a type of intelligence that was built into the vehicle, into those airplanes way back, not with computers, but with mechanical devices, right? So, but as the era of computation has come and things are getting faster, we obviously have new technologies emerging, and how are we going to apply it? We need to be do that with a bit of caution, right? Today is going to be a little bit of switching gears. We are going to get down into the nuts and bolts of what it means to look at digital mobility. So we're going to have 3 exciting panels. The first panel focusing on what is the Bharat multimodal mobility stack? What does it mean to different people? And what does it take to build it? And what does it take to build it to scale? So that's our first panel. Where our second panel is going to be, wonderful, you have a stack, but what do we do with it? Where is the data going to come? What are you going to use it to analyze? What are the digital twins that you're going to model, right? And how are you going to do that modeling? And what are the problems you're going to solve, right? And that will kind of give the segue to panel number 3, where we're going to be discussing what are the use cases, right? And interspersed in between, there are going to be a couple of projects that have been done in year 1 as part of MInT, which are kind of, in some sense, reflective of the building blocks that we need to put in place in terms of digital public infrastructure to realize the stack, right? So we'll hear from the Loop project as well as the bus signal priority project, where very simple but very concrete examples of how we can look at the digital kind of infrastructure coming into play and helping us solve very real problems, right? Now to kickstart all of this, we are going to have Mr. Abhik Chatterjee from Boston Consulting Group can share what they have been working along with JICA and some academic institutions as well as thought leaders on what is called as the Delhi stack, right? The Delhi stack is to model the urban mobility in in the city of Delhi, right? So without wasting much time, let's get started with day 2 of the premier digital mobility conference of the world, okay? The MInT Mobility Summit. We'll be inviting Mr. Abik to kind of share of the thoughts on the Delhi stack. Abik, we can't hear you.
Can you hear me well?
Yes, wonderful.
Okay.
Thank you, Abik.
Yeah, thank you, Professor Ramki. Just a small correction. Actually, I would love Nagano-san to also kind of lead and join this presentation. I know there was a bit of the, let's say, both of us were trying to be there in person. And first of all, apologies for not being there. But I thought it will be a great opportunity for everyone at MInT and also at IIT Chennai to have Nagano-san also co-lead this session along. And hence, if it is okay, we'll both do it together.
Absolutely. Welcome, Nagano-san, as well. Very nice to see you. Please.
Sure. Dr. Ramki and the team, thank you very much. This is Yushi Nagano. I'm the head of JICA DX Lab at the Japan International Cooperation Agency, JICA. And I have been leading this Delhi transport stack and broader DPI agenda in India and across the globe. And Abik, just introduce yourself.
Sure. Hi, everyone. This is Abik Chatterjee, Managing Director and Partner from BCG, Boston Consulting Group. I'm based out of India and I lead our tech and digital practice across Asia Pacific. Have had the privilege of working very closely in the mobility space along with JICA for the last 2+ years. And first of all, extremely thankful also to MInT, to Professor Ramki and other members from IIT Madras in terms of discussions we've had. And we would like to share a bit around our journey and learnings that we have faced for the past 18-24 months with this elite audience today. Thank you.
Sure. And without further ado, let us have 10 minutes or so to, rapidly run through our what we have been doing and what would be the implication for the future. And before jumping onto the contents, that everybody may be aware that there is mobility landscape and challenge. But just a little bit, recapping it. The current transport network in Delhi, largely we have metros and buses, rapid rail, and other micromobilities and Uber and all of the world. And JICA, by the way, has been financing Delhi Metro for 25 years since its inception. And currently, Delhi Metro, the largest metro network in India and the second largest network in globe as well, is around 394 kilometers of the network and approximately 300 stations and 12 lines. And the buses...
Nagano-san, just a second. I think the window that's been shared is not on the slideshow mode. I think the other window is shared.
Oh, right.
Yeah.
Already.
Can you make it full screen? I think it will come up. Otherwise,
sure.
Yeah, you'll have to get into presentation mode and then share the screen. I think that will work.
Right. Sure. Got it. Yeah, while I'm playing up, the point is that so Delhi is, massively, there is a massive metro network and a bus and Uber and all of those mobility space, mobilities, but still there is congestions that's getting really worsened. The population's doubled, 120 lakh plus motor vehicles on the road, and 3%, 5% every year increasing. And out of those, traffic index and air pollution index, that is always, unfortunately, ranked as one of the worst ranked traffic congestion as well as air pollutions globally. So that caused at least $10 billion loss in every year for the proactivity of the traffic, caused by the traffic congestion and others. So that's based on that. And as I said, JICA has been supporting Delhi Metro for 25 years plus. And this is back in June 2023. I put up this just one pager. How living in a digital age and AI age, how we will intervene this Delhi's traffic and the transport mobility issues, leveraging our supporting assets on Delhi Metro and other PTOs. And we'll not go in detail, but we have basically identified like 3 layers. One is the enterprise public transportation operators level, and on the policy, and then Delhi government level, or the anti-Delhi level, then the Indian level, and the policy framework and the technical build on the vertical. And in a nutshell, that we think that what we, JICA, is strongly working on each enterprise public transportation operators to transform their operations. I mean, so data transformation, as shown at the bottom. We strongly believe that there is a need to create the framework and then technical stack at the entire Delhi level to really leverage the mobility-led innovation ecosystem in the city. And that will be in sync with the India government's entire effort of India Stack and Bharat Mobility Stack. We strongly believe that our endeavor in Delhi will be infused and contributing to the your country's aspiration for the national transport stack for extend to the other cities, other regions, and also the global south. And so that's the basic sort of ideas in 2 years ago. And this is kind of a transport stack basic framework that we have. We have conceptualized. So basically, along with Center Data Exchange DPI with foundational blocks, with Mars framework, data hub model, and DPI data exchange protocol. We put, as long as the core principles or the interoperability, practice design, trusted and secure, and agile and scalable, and open source. We identified 4 value pools is as a kind of the pillar of our transport stack journey. One is the transport operators. Second, green as a governments on the right bottom. And third, that we believe that this data enabling ecosystem build will surely benefit for the businesses and the entrepreneurs to innovate and create solutions, functions on top of it. And all of this will be then bringing a benefit for the citizens, better mobility, safe mobility, inclusive mobility. And so that's the broader concept. So the 4 key beneficiaries, again, transport operators, governments, businesses, Delhi, how centered on this DPI data exchange stack, how we can really push forward this kind of benefit is something that we took journey back in June 2023. And we have launched officially this transport stack back in October 2024 last year, together with Delhi Transport Minister, as well as with key ecosystem stakeholders, and gather at one and celebrate the moment. So I'm now really going in detail what is actually transport stacks, integrity, and what's in and what's it's coming. And this is a very detailed and busy slides, and it's representative and non-exhaustive. But in a nutshell, the transport stack is on the bottom is basically data, scattered data in the metro, buses, rapid rails, and driven autos, and not only the mobility, but also parking and registries and others. Any mobility transport related data currently scattered across space. While on top on the services layer, those apps, Mars apps, any business ops analytics operators, and even ONDC and others, and the PTOs as well. Those are the kind of the players who really wish to consume the data to create services and functions for the better, and then serve to the citizens. And what we have been creating is basically in the middle, as kind of the combination of DPI as a data exchange with together with data transformation, and on top of it as a platform services and DPG and functions like metro, all the journey planning, back and right, ETA calculators, ONSG seller, and a buyer from the transformation side. So that in a narrower definition of transport stack is this in the middle, and the broader definition is that this entire data-driven ecosystem that we have been, bit by bit, as a been Lego blocks that we have been creating. And this entire ecosystem driven by the data will be continuously getting matured through the enabling that this data looping and feedback for those services and for those data users. Will we give feedback and join in the data provider as a data providers also, and data providers would like to also use the data as a data consumers on the service layer, so that multifaceted, complex but constructive kind of data-driven ecosystem is something we are going to create centered on this DPI approach. But before passing over to the next page, if Avik, would you like to have a little bit of an nitty-gritty technical things on this slide? Happy to have your intervention.
Sure. Thank you for kicking us off, Nagana-san, on this one. So as we have gone through both the development and deployment of the transport stack, and I take a cue from what Professor Ramki was also mentioning in terms of, whilst there is data and tools that we have, how do we achieve adoption? Because I don't think in the mobility space there was any time a dearth of, let's say, tools or technologies. A big problem had been integration and adoption, and then the uptake out of it. Because even if we look at when we started at Delhi, there were different apps that were already present. In fact, we have Professor Biani also here in the room, with whom we have partnered quite closely as a part of build out of the Delhi transport stack. And there were other apps was also there. But one of the key challenges was that the adoption, I mean, how much is the digital consumption in terms of the offering? The second part is, how do we really drive up and get more and better data, as Nagano-san was mentioning? And the third aspect is, as we build out a stack, and this we have now realized that in the public space, there are two ways to build out stacks. One is very use case based, wherein it is more vertical adaptation of how we build, or do you build out a platform? And often we realize that if you need to build out a platform, ultimately the world and the citizens and people like us like the services. We are always consuming the cake top down, whilst the DPI world constructs the case, if I would say, horizontally out. And hence, as we look at stacks, and as Digital Bharat grows, and as we create stacks of tomorrow, I think there will be a balance we have to play out in terms of creating stacks and also meeting the requirements and driving uptake, because it is almost like the seed stage of a startup, wherein you will need to get a certain type of people to come on board. Specifically on the technical pieces, two bits of learning. Number one, our integration with a whole bunch of the other India ecosystem could be across, for example, Nammayatri builds that are already in place, ONDC, etc., are extremely valuable because it allows us to multiply the impact that we have. Point number two, we also conducted, and we will, Nagano-san will touch up in a bit, is the entire innovation hackathon, wherein few of you were also part of it, and it was great. But the stack just allows a plethora of non-participants to now come and innovate. I think that is where the stack becomes powerful, because we are shifting the point of innovation from the bottom of the stack to essentially the top of the stack. Earlier, we needed to get to, let's say, each mobility player in order to get OD pair, or in order to get, let's say, real-time dynamic information. But today, I am shifting that point of innovation from my source, which is from my bus or the metro or the last mile, to the top of the stack, wherein good data can exist, it can get combined, and then it can offer greater opportunities to not only the transport operators or, let's say, other agencies to drive use cases. The other important aspect, and I go back to the circle frame that Nagano-san did touch upon, wherein a lot of the a lot of the mobility information was stuck within the mobility corridor, but the ability to use that for broader city planning and for broader set of use cases has become important. So essentially, as we grow the stack, our only humble intent is how can we grow more data from transport operators, couple that with citizens, as well as all third-party data, because today third-party data is often proprietary, held not by the government or by the state. It is held by, let's say, startups or individual companies. Is there an avenue wherein IP can reside on top of a stack and more services can be created, and hence the combined value proposition can be offered to all the four stakeholders in a very meaningful manner? Obviously, the journey has been not possible without support of a lot of the different participants, but we genuinely believe that we've just taken baby steps into this journey, and a lot more has to happen as we look at value, which we will just look at in the following page. Over to you, Nayana.
Sure. Right. As Avik touched, that the multi-stakeholders, ecosystem built with bunch of the players on the service layer, private sectors and ONDC, IUDX of the world, I mean DPI, DPGs, and the TPOs, and so it's a constellation of the ecosystem is quite important, and we have successfully evolved in sort of the partner constellation. Currently, if counted very carefully, it's like a 15 to 20 plus of the players regularly and continuously engage with our this ecosystem up and running. And so, and with tens of hundreds of entrepreneurs, really sparking innovation on top of it. So, as Avik mentioned, really shifting the gear and play the game for more like a use case driven service layer entrepreneurs innovation ecosystem with this foundational core constellation of the innovation ecosystem partners is something that we believe is quite crucial when thinking about Bharat mobility stack. And I know that time is running out, but a quick a retraction of our ecosystem and its impacts. On the channel side, we are working on a One Daily app and chat on others, and we have around 100K plus daily active users, and some of the core functions that we have been embedding into it, which we calculate around 20-30 minutes per citizen's daily time saving. And I think that's massive, considering about a 28 million population in Delhi. And the weekly digital ticketing, still it's catching up, but it's around 341,000 of the digital tickets. The integrated ticketing is now happening in Delhi. And on the bus side, as I said, there are 8,000 plus buses in Delhi, and currently we basically covered most of 100% of them, and being on the analytics and dashboard. And those bus operators every day, every minute, actually using those BI, AI analytics engines for their digital making and better optimized bus operation. And for the data subscription side on the open data sources, still not, it's still catching up, but we have currently on our website on the open data platform around 180 plus data parameters available, and around 7,000 users on the web, and active registered data users currently across 20 countries, or 250 plus. So that's early traction, and we have been strongly pushing adoption and the use of this platform. And as Avik mentioned, and Ramki kindly participated as a jury as well, we also created an innovation challenge for driving further transformative solutions from the market. And we got good enough number of the 300 plus submissions from students, entrepreneurs, and large corporates for their innovative ideas, along with key 10 themes. And we selected 5 winners back in February. And currently we are now working on those use case right. And not surprisingly, most of them are pretty much AI driven, very, very AI native driven service providers, be on the data source side or the function side or the service to citizens. Regardless of their layers focused, it's pretty much AI powered. And I think this stack approach or DPI will naturally be injecting and really amplifying the efforts of AI on both bottom layer data side as well on top of the cake. And last but not least, we are currently thinking for scaling for 2 aspects. that transport or the mobility in city is, we believe, and maybe, by the way, that we JICA has been financed from Chennai Metro as well. But you look at Chennai metro network is going to be massive, and the transport, considering about even Japan city, is core function of a city. And so that hence, we believe that transport stack can be a city OS bedrock. And currently we are on the journey. If you go starting from the bottom, we created transport stack 1.0 with core data exchange enabling functions with platform services and some of the key citizen-centric mobility services. And now we identify ourselves as transport stack 2.0 at the bottom middle, and further data enrichment and creating advancing AI use cases a bit by bit with bunch of the other DPI DPGs integration to really widen its functions and its arm strengths. And maybe in next couple of months or a year to come, we believe that it's going to be transport stack 3.0 to further, extended the global SaaS, as well as AI-driven autonomous transport system in itself. And this will infuse to the broader concept of the city operating system or smart city architecture, whatsoever called. And mobility itself, but the safety, security, or the infra resilience, or the healthcare, and whatsoever. All those, core key city operation, key smart city use cases are directly, indirectly supported by the mobility and the transport. And we strongly believe that the enablement of interoperable data exchange and mobility-led ecosystem in that city naturally really push the city to elevate completely digitalized AI-driven operating system environment for its operation. That's scale one that we believe in. That's it's on the quality side. And for the quantity or the scale of the geographies, by the way, JICA is financing around 7 metros in India and 17 metro networks globally, and reaching up around 500 million citizens globally. But what we believe is that we can really now already in place, in progress for the Mumbai transport stack and the Bangalore transport stack. And currently we are trying to start thinking about Manila transport stack and Jakarta data exchange system in the mobility, so that we have codified our approach and created a transport stack wiki at the GitLab and a repository and enter framework reference model, and whatever building blocks. We are currently going to open up and make a kind of a technology ecosystem around that. And it's a kind of DPI frame with open source DPG building blocks, which enable speedy, further leapfrog expansion of this idea. And so that's something that we are currently thinking, so that go deep, further embedding into the city, as well as make open to drive the extension for the region within India, other cities, as well as going broader global south regions. And maybe Abik, you just have some word or two, and let's conclude our session.
Yeah, no, I think you've covered it nicely. Just maybe a couple of last points. One is how we codify this from a DPI, DPG perspective so that multiplication and replication can happen. Because one would argue that if it took 18 months to create the Delhi transport stack, what will it take to create any other city's stack in, let's say, 9 or 12 months? And what kind of acceleration can be provided? Because the starting point for each city is very unique. Some of the, let's say, the modalities are very unique. I think that has been one. Point number two is, I think, obsession around how do we push for adoption? Because there is a classic 10-20-70 theory that exists in business enabled by technology, wherein we always believe that that ultimately the impact caused by 10% of the models, 20% and technology, and 70% by citizen-centric or business-centric usage because ultimately it is a change management problem that we are also addressing. So whilst we will have a plethora of tools, how we, through policy, through excitement and ease of usage of many of these solutions, make it work is something that we will do. And lastly, I think, as again I say, we have taken some humble baby steps in this journey. We will continue to learn and enrich this with the support of, I think we are in a very privileged place to be in a country like India right now. We will technically add another India in the next 7 years and add more startups and innovation funnel. And hence, creating such playgrounds wherein innovation can happen and acceleration can happen would be just fabulous. So, and no better place than IIT Chennai and IIT Madras to kind of have such a discussion on. So, thank you for the opportunity from my side, Nagano-san, for you to maybe give some closing remarks and then, yeah.
No, I mean that I know that we are running out of time, but that's that. And then I know that we're going to have a panel session as well. But so back to Dr. Ramki, but hope that our presentation will have a little bit of the learning from other participants. Thanks.
Yes, indeed. It was a very enlightening session. In fact, we thank you, Mr. Abik and Nagono-san, for walking us through from idea to implementation of a model for urban mobility. And we certainly look forward to how it's going to be implemented in other cities as well. So thank you for joining us online and giving us that enlightening talk. With this, and on behalf of MInT, I thank you for accepting the invitation and joining us online. We will now move on to the first panel of the day, which is the session on the BM3S architecture. And I invite Professor Geeta Krishnan, the moderator of the panel. I also invite the panelist, Professor Pravesh Binyan, Indra Prasad Institute of Information Technology, Delhi. So we will be having the panel as a combination of online and in person. The second is Mr. Sujat Nair, CEO and co-founder of Foundation for Interoperability in Digital Economy. Mr. Manish Srivastava, CTO, eGov Foundation. Dr. Ramachandran Balakrishna, Principal Scientist, Caliper Corporation. Dr. Vijay, Indian Institute of Science. Mr. Dayanidhi, Director of Engineering and Growth, Namayatri. Welcome. And with this, I hand it over to Professor Geeta.
Thanks a lot. And of course, we'll also have Nagano-san and Abik also available online, right, to be part of the panel. First of all, I think we thank both JICA, BCG for sharing their experiences. I think Delhi perhaps is the most intimidating of cities to start out with, and it was great for them to have taken that big challenge, shown how to address it head on. I think there is a lot of learnings there, but something that was highlighted also is how do we take it to maybe tier 2, tier 3 cities also, right? So we have to think about a solution that can span the country, right? Not just the big cities. So I think that's something that we will discuss. So the way we're planning to organize this panel is we'll have each of the panelists make some opening remarks. I know a couple of them also have presentations to share, right? So we will start doing that, and then we'll have some questions and answers among the panelists and the participants. So to kick off, maybe I think we have Professor Pravesh Binyan from IIIT Delhi. So he was to join in person, but I think he was caught in the storm yesterday in Delhi airport. So he had to return back. So Pravesh, thanks for joining us. If you would like to share your presentation, and then we could get started with your
thanks. I'm just sharing my screen. Please let me know if it is visible.
Yes, we can see it.
Can you see the slide written 2015 in it?
2015, yes.
Yes, great. So I know that I have only a few minutes, and I'll just I want to start with thanking IIT Madras, because this is exactly where my journey started 10 years back when I presented this, that India does not have a big data problem, but a big data problem. I think that's where I jumped into transportation industry. And, Abhi was talking about Delhi transport stack being built in 18 months. I would say, more like 84 months. It started in 2018 when we first released the 2000 buses data. In this open transit data run by Delhi government, we were their partners, and from there in 2020 we built more digitization. Went to depots, build tools for them so that they can start putting simple, schedule data and, all that. We build tools for them. And then in 2021, we went from, data to ticketing, etc. But I think the real thing came in 2024, and thanks to both BCG and JICA for partnering with us. I think whatever we did before was taken to another level, much more systematic, much more nuanced, thanks to the Delhi transport stack. So, Nagano-san has already talked about it, so I'll not discuss too much. But I think this is something that everybody should see. This is the rise of ONDC ticketing in the last 6 months since the transport stack is on, and you can see a very nice, upward looking curve, not just in number of tickets, but also in number of participants. So we have like 4 or 5 participants already, using it. I think this is the biggest success of transport stack, I would say, thanks to ONDC and thanks to the whole ecosystem that we have. So this, and I also want to just spend 2 minutes on my understanding of challenges and learning from building multimodal transport stack. Of course, Nagano-san and Mr. Abhi talked about very high level and very, challenges from a different policy perspective, but I want to talk about from an operator perspective because, I would call myself as an operator here. So I think the biggest learning that I had is, setting the expectation right about, what is the outcome of a stack, and it should not be, that you'll see very early results right away. So our expectations should be very, very, precise about the fact that it will take time to build it. It will take time to, mature it, and that's absolutely right. There is no need to hurry about anything. We have to, play a very long-term game. It's not a affair, it's a marriage. And in a marriage, you will immediately see the problems as soon as you get married. Of course, affairs are nice, but marriage is difficult. And I think transport stack or any stack that involves multi-stakeholder is like a marriage. You have to be committed towards, building it and sustaining it. I think it's not a project. It's something that you have to say that I will die with it. No, that's my view. And I would say both, BCG and JICA has been, our support in that. The stack should be really open. When I say open, I mean really open, not with 50 or, various permissions that is required from bureaucrats or the government. It's a public data. We should treat it as that, and it should be really open, and there should be no, accessibility is very important. More the accessibility, more the usage, more the feedback, more the robustness. And that can only happen when the stack is open and least amount of admissible, admission control in it. This is a very, very, I would say very, controversial. I would say we should discuss more about quantity than quality initially, because data improves over time. You will never have perfect data. But when you have more type of data, for example, in details right now, we have parking, we have last mile, we have, various data. Not every data is perfect, but because we focused on the quantity initially, now we can focus on the quality. So this is to me, this is a very counterintuitive learning that we had. The second and the last learning that we had is on standardization. Now, standardization is great. We should have certain minimal standards. We should have uniformity, but too much standardization is also bad. We should create room for, more, I would say innovation, and more innovation requires less standards and more opening up things. So that is to me, it's again very counterintuitive. And we have seen that in ONDC, where we actually did not follow everything that ONDC said, and we built our own standard around Delhi. And I'm sure every city will have its own specifics. So one size fits all approach is generally a bad idea. So these are my learnings. I'll not take more time. Thanks so much again, Geeta, for inviting me since 2015. So thanks so much.
Thanks, Pravesh. So 10th anniversary. It's a marriage, not an affair. Great. Now I invite Sujit to perhaps share his thoughts. Sujit is online? No, not yet. Okay, great. So then I'll move on to Manish. Manish has been our guardian angel, so to speak, right? He's been telling us how to get these at scale correctly, right? All the solutions we built. So Manish, your thoughts, opening remarks.
Thank you, Professor Geeta. Thank you, Professor Ramki. This means last 1 year has been a fascinating learning journey for me personally, as well interacting with a lot of experts here. Um, uh, I just wanted to briefly introduce myself and what we do. Of course, I'm the Chief Technology Officer at eGovernments Foundation. It's a not-for-profit organization, was set up by Nandan and Shrikant in 2003. We started with broadly when the whole IT thing was happening in Bangalore, and Bangalore was, as we know, was growing fast. And 2003 was all those periods was pain of the city growing very rapidly, and hence one of the focus was how do you use technology and digital infrastructure to improve public service delivery, and that's where Eager Foundation was set up last 20 odd years. Our mission has always been on focus on how do you build leverage technology to improve public service delivery, and that's something that we want continue to do. Initial days were always focused on individual departments within Bangalore, BBMP. A lot of the siloed systems that you see was built by us in very early days. They still run in Bangalore Municipal Corporation. But then we realized we need to do this for all the cities in India, and India has around 4,800, 5,000 cities. How do you do? And therein, our journey started of how do we think at scale? How do we get things working at large scale? And of course, Nandan kept pushing us in that direction. So we did Chennai. GCC runs an infrastructure. It's a city ERP kind of system that was built, is actually built by Eager Foundation. Incidentally, we maintain it also today. Chennai is of course working. Then we did AP. We built a multi-tenanted systems for all the cities in AP. So AP runs on a shared infrastructure where all cities are deliver all public services on a shared infrastructure. Then that we tried replicating that to Maharashtra, etc. We had a bunch of failures because we realized that ERP kind of models don't scale, and this is early days, and that's where we started. By the time a lot of the learnings from Aadhaar, UPI had started coming back because our co-founder Shrikant was the CTO for, by the way, Aadhaar. So once all of those learnings started coming back, we started moving to a more stack-based approach. We delivered Digit, which is a stack, an open source public service delivery stack, firstly for Punjab. A lot of services, 5 services went online in just 90 days. We are able to build local capacity within Punjab to be able to maintain and manage it, which is a huge learning for us. You can't just build the technology stack, you also need to build the people stack within the government to maintain, manage it. Otherwise, the stack comes crashing down. Just the technology doesn't work. So you have to build local capacity within each of the states and governments to be able to maintain and manage it. And this could be even market capacity, right? So Orissa did this with PwC. So because Digit was open source, PwC took that and deployed it in Orissa. They maintain and manage it. This is called Sujog in Orissa. So this got the journey going. So today, the local service delivery stack is deployed across 1,200 odd cities. Mahua has, of course, adopted it as Upyog, which is the governance stack for India, and now the government is also pushing it to across all the stuff. So that's been our journey, and today we, of course, work on water sanitation, some of the other places, some of the other health. We are now in 9 countries in health. So this journey for scale, how to search for scale while we build things, how do you also scale them across large is something I know there was a lot of discussion on that, and look forward to that collaboration as from the work that is being happening in the Delhi stack is very exciting, and look to partner with and see how this can be made available to all cities in India.
Thanks, Manish. So I invite Rama to perhaps give his opening thoughts.
Hello, can you hear me?
Yes.
All right, thank you. Thank you for inviting me to say a few words in this panel. It's been fascinating to hear the speakers so far, mainly because they've actually built stacks, right? So it's not they're talking from real experience of uh, having gone through the process, learned what works, what doesn't work, and so on. I'll come with a slightly different perspective. My background, of course, is in transportation modeling. Um, I have throughout my career, I've been working on collecting data and building simulation models, large-scale transportation models, and that kind, right? So if you're looking at the perspective of what a stack like this might actually help, how it would help the different stakeholders here, the primary focus is multimodality. From an end user perspective, if you're looking at how you're going to serve the public, you need different modes to compete. And when I say compete, it is not necessarily at everyone else's expense. It needs to be a collaborative type of competition where you're providing alternatives for people to actually evaluate and find the best solution that works for them. At the same time, the collaboration also should be at the point where some of the solutions can be joint solutions, right? I mean, there can be modes that work together to provide solutions and so on. So when you have that kind of multimodal focus, you're building a system-wide stack. You need to have something that replicates the entire system so that any stakeholder, this is also a multi-stakeholder problem. It's not just the end user who's trying to use this. You have multi-stakeholders. There's already been mention of entrepreneurs and academics and the government and so on. Everyone is trying to help with this puzzle. So there are multiple stakeholders looking at this from different perspectives. And so every stakeholder that comes to the stack needs to be able to access it and take something away from it. And also hopefully in that process contribute to that stack, right? So when you're trying to build this, there are three different components. You have the digital twins, so to speak, which everyone is trying to utilize and leverage and build solutions off of. But those digital twins have component models in them. And different people can bring different parts to that. No single entity will be able to provide the entire digital twin. So you're going to have a lot of collaboration, give and take, and so on. And those models that constitute the stack will need data support, right? So there are different challenges and opportunities here. One of the key challenges, I will use that word standardization. I know Dr. Pravesh walked away from that a little bit, but I think it's useful to have standards from data access perspective and model access perspective. It's very difficult for someone to come and access a stack if there is no documented way of figuring out what you can get out of it. But I will agree that those standards will have to evolve. Everything will have to evolve. The stack will have to evolve. The data collection will have to evolve. Standards will have to evolve as well. And all of this provides great opportunities because each one of us comes from a different perspective, different line of expertise, so to speak. But often we work independently of others. So there is a great opportunity here to actually leverage all the learnings and the expertise that we all have gathered in different fields that are all mobility related, bring it all together, fit the pieces together, and create this digital twin that everyone can actually benefit off of. And my final thought here will be, given that the topic of this summit is AI, AI is thrown around fairly loosely these days. It seems to be a powerful tool. It has many definitions depending on whom you ask. It used to be called model, then it became machine learning, and now it's AI. Of course, it's slowly evolved along the way, but there are some commonalities in this in these terminologies. So while they are powerful and they can definitely help us in different aspects of the stack, I think there is a key opportunity here to be critical about what these methods can do. Be a little more cautious about the claims made about them, but also be very optimistic about what they can do for you. So I think that skeptical viewpoint of AI can be very useful in making sure that when we apply them, they're applied the right way, they're applied safely, so you can get the benefits out of them without hopefully some of the negative effects that we're already beginning to see with it. So that would be my high-level perspective here. I think I'll hand over to someone else to speak.
Thanks, Rama. I'll definitely come back with some questions later. And yeah, Dr. Kowali.
Thanks, Geeta, and thanks, IIT Madras, for inviting me. I'll have a quick presentation. Try not to make it too. Can you see my screen?
Yes.
Okay. So I'm Vijay. I'm at Center for Infrastructure Sustainable Transport and Urban Planning at IAC. I'm a research professor, which is essentially a professor of practice. That means I worked in the industry for a long time after my PhD, about 22 years or more. And then I've been in academia for the last 2.5 years now. Okay. What I'm going to talk about is my industry experience and why I got into academia to an extent. But I am architecture, data standards, and protocols are all dear to me because I face the problems, right? I worked on multiple of these projects, most of them as an expert consultant, as the team leader for most of these projects. I also worked as a system integrator for the Hyderabad Adaptive Signals, where I was the project director. And then it is a completely different experience, and you don't want to do any standards, anything, right? But this, whatever I'm going to talk about, is from that perspective. For me, it is not about stacks, right? For me, I'm a civil engineer with ITS. This is the standard US thing. What we talk about is operations, right? Operationally, what you want to achieve. So for me, the most important thing is this transportation need. What is the need that I'm trying to satisfy? And am I able to satisfy? For that, what are the things that are required, right? And if you look at this diagram, it comes down to having the ITS technologies. But the biggest thing is the local ITS marketplace. Okay, where we struggled a lot in most of our project is what is available in the local ITS marketplace. It's nice to create it, but then you need to have vendors who can provide what you want, right? And once you have this ITS technologies, of course, the budget comes into picture, the ITS solutions, improvements, and then the community benefits. And the second you see this kind of question, you'll immediately say, hey, I need to get this ambulance out. I need to have some kind of like connection to the signaling system. So the ambulance should talk to the signaling system. That's where I need standards, protocols, everything to do it. But when it comes to India, we have one more layer that comes on top of it. If you look at US and any other country, they have an Opticon system that basically talks, the ambulance talks to some receiver on top of the signal, and that connects to the controller. We have one level of issue where we are cost-conscious society, right? And because we are a cost-conscious society, we already have some GPS units in this, and we are saying, can we use the GPS units to talk to the controller? Okay. And that is where most of my challenges come, because the accuracy of the GPS unit that we have is not very high in these units, right? And more often than not, whenever we try to do this in our projects, the ambulance would have crossed that because of the latency, because of everything else. So then the 5G comes into picture, then you're talking about the GPS accuracies. So the standards for the GPS accuracy become very important. Of course, the protocols to talk to the controller and everything becomes important. But it is not just about talking about at the high level saying that ambulance needs to talk to the signal controller, but also at the cost and the local market conditions and the persons that are there, right? Again, we know that sustainable transportation requires that people don't get frustrated. What do we do? And when we talked about this kind of conversations, of course, the Mysore ITS project was the first one that I worked on, 2011, one of the first projects in the country where they looked at the whole city rather than just a pilot of 20 vehicles or something, right? 500 vehicles, we put devices. And this is the architecture, again, layers and all that. For me, these are all nice, but the one that I understand better is something more like this, right? The one that solves is that I have a bus, I have some units within the bus that are there that talks to the GPS. And again, looking at it. In Mysore, the project had challenges because this device that you see, the welcome board that you see inside, was already installed in the bus. And we were putting all the other devices in, and the welcome board protocols were not known. Okay. So at that point, we were like, okay, protocols have to be known, right? We need to, and they were refusing to share the protocols. We don't even know if they had any kind of real protocols because it's a private company. Okay. The next project I did, because KSRTC was very happy with us and also the vendor at the end of it, Mysore ITS still works, which is impressive and surprising, is that the VTMS project for the state of Karnataka. And in that one, they said, hey, we need to get this information of the bus, how many seats are available to a bus stop. Okay. What that means is there is a ticketing system called Airavat in KSRTC. And from that, you need to get the information, how many tickets are already, how many seats are available. And again, all kinds of challenges, we got stuck, okay? Because again, you need to have the information where the bus is, which is the closest stop, how are you like, does it have connection, and all the various issues that are there that goes with it. Again, what I think is the APIs that are required, and some of these are not problems anymore, honestly, with the backend and everything that Sujit is going to talk about and what Delhi has done. But at that point of time, this was a big challenge because these applications that were developed, which is again a third party, right? It's a different from the guy who's putting these devices. That third party guy is not able to create. He never thought about that he needs to give this information to somebody. So he's not set up. From a use case perspective, we need to talk about, hey, I need this as a use case and what can I do with that, right? So the framework for integration, obviously, you have the signal control unit, the UBS2 came into picture, and then we are messing it up, of course, and that talks to all the devices in the bus, right? And all the systems are going at and talking about it. One of my other big projects was Hooghly Dharwad, which where we did, and you can look at this whole thing. What we did is the fare collection system, we had the CAD AVL systems, we had like the signaling system, and this is part of it. Okay, so I'll talk because here the architecture becomes very complex, but almost in all of our projects, we talk about the physical systems where they are located and the communication that happens, right? The communication is very, very critical in terms of talking about this. Okay. So if you look at just the component diagram, because sometimes we do the component diagram, then the architecture diagram, then we have a data flow diagram, all the things to ensure what is happening. You can see that we have so many systems that are there. This is about 112 crores at that point of time. So it's pretty large project in 2014 also, 2014-15. So fare collection system, CAD AVL, PIS, incident and all that. And part of the reason why we put it the way it is, and it's such a complex project, is in Mysore, we had one of the big problems we ran into it is the depot, the schedule of the bus had to be entered in two different places. One in the depot management system, which is mostly a written thing. And then in the bus itself, you need to enter it into the computer. And people never wanted to do it. So we said, oh, we need to integrate all that. Net impact of it is new challenges. And the other part is, if you look at these systems are not by the same vendor, right? They're brought by, one is by AFCS vendor, by AVL vendor and all that. And each of this, and then the signaling system is there. So you talk about all of this. And that's where the integration comes. Of course, the traffic transit signal priority is a very useful thing once you have this information. But again, as I said previously, the GPS is what we are using. We are not using a separate device. So there are challenges on that. Then controllers, when Pravesh talks about standardization not required, I get, my take is that interoperability is the most important thing. I want to be able to replace one vendor with the next vendor because this one and with the least amount of effort, right? So standards help me get there, right? So we always have challenges with, you get a system integrator for a signal controller, the next guy won't, like, you can't get another person and have the same backend system. So there are two separate systems. In most cities, we have two separate systems for this, and those are challenges. The third one is also, of course, when we have all this data, the question that came is that, we can do our timetabling using both ridership data and also travel time data, right? Then how do you get it? Because it was one system integrator, he did all these things, but it took a while because there are different vendors internally, right? As far as we are concerned, we said do it as a single system. But then the guy who is good at AVL might not be good at AFCS and stuff, okay? Of course, you would all seen, and Pravesh is probably the best in the country in terms of creating these technical standards and is able to transfer. But where we are having problems is in the operations. I saw that the Delhi stack was talking about it, but we still are in the backend and various others that we have. But we are still not, I haven't seen a solution where everything is seamless, where we can get the EV data, the battery information and all that. And would be nice to see these use cases at a separate level and say, how do I get this use case and how does my stack support those use cases? Okay, right. That is something that would be nice. Bhubaneswar is one more complicated thing in the smart city thing, where we looked at traffic, transit, parking, you name it, and everything was there as part of that system. About 750 crore system. And this is where the integration is, where you're talking about traffic, traveler, emergency, and transit. In Chennai ITS also, this is the thought process where all these get integrated. Again, different vendors. So what are those standards? What are the protocols that are required that they can expose beforehand? And we get only of them. So in multiple projects of ours, we wrote GTFS. We never could check it. In multiple projects of ours for signals, we wrote NTCIP. We could never check it, right? Because certification costs money and all that. But these are all things from a use case perspective you need to think about. From a system integrator perspective, who are those vendors that are available in the city and what are their capabilities? How can I replace one vendor with the next vendor? Okay. MAS is where I think amazing work is being done, what Pravesh is doing, what Sujit is doing and all. We are trying to get a single piece so that we talk about journey planning rather than we are talking about this. What my use case that is of greatest interest is the incentive scheme, like a loyalty program. If I travel more than 100 kilometers in a month, I should get some kind of thing so that you're pushing all modes of public transport together or all the modes that you accept as good for the society rather than the private mode. right? So those are the various thoughts I have in terms of it. That's all I have, and thank you.
Thanks,
Good
Vijay.
night.
I think quite a lot of experience there, and I think a different perspective, right? Who is the user is also something you need to be mindful about. Of course, we also have Namayatri here, and they were one of the first to take the ONDC Beacon protocol and build a mobility solution on top of it. So we have Dayanidhi here. I request him to give his opening remarks.
Thank you for giving us opportunity, and happy to see all of you in one screen. I think we have met individually, but this is the first time we are meeting together virtually. Great. So just quick intro about ourselves, what exactly we are doing as Namayatri. So we are a mobility organization. We hived off from JustPay. JustPay is a payment company. The same team who have built Beam for India, which PM have launched, and we've been the pioneer and the initial team who defined the UPI protocols and the common library, whatever we are using it in all the UPI apps. The same team has been building this Namayatri as well. What is the differentiator from other apps, other mobility apps? We anchored on a couple of things. One is tech part, which is anchoring on open, and other side people centric, where we strongly believe enabling community will be the next big leap in the ecosystem. So that's where been our anchor point, and we've been doing that. Bangalore, I think we are doing close to 1.5 lakh rides per day. We enable drivers in last 1 year to earn close to 1,000 crores of rupees, which is direct to driver model. So this is broadly about us, and with the experience of UPI, whatever we have done, we want to apply same in mobility as well. So UPI, we are doing close to 250 million transactions per day. Mobility also has such a big scale, but that requires applying the innovations. I think I can see that there are lots of innovative solutions being there, but applying it practically, I think it requires a lot more collaboration with stakeholders. We call it government, Sarkar, Samaj Sarkar Bazaar. So it has to be worked in that way, then we will be able to make a difference. So that's where we anchored. Initially, we started with our auto and cab model. We scaled it to multiple cities. Then we worked with multiple governments, Kolkata and Chennai. We are working with Kumta on integrated ticketing. So that's where we are trying to get into the public transport sector. Kolkata, we are trying to roll out a small device, and with one device, we are trying to make location tracking available, plus the speed and all the intelligence part. Basically, we are trying to reduce the cost of enabling that bus as an intelligent transportation into the intelligent transport system. So that's one part we are working. Kumta, we are working with multiple stakeholders through Kumta, which is, I think, first off in India, we are working with Southern Railways as well. Southern Railways is opening up UTS, local suburban ticketing, and CMRL, metro ticketing, and bus. All put together, multimodal booking, you'll have one single QR. So you'll just book one single ticket, you'll have one single transaction and one single ticket for all the three modes. So that is something we are working with Chennai. I think soon the app will also be live launched by our Honorable CM as well. So that's where working with government and private entity like us, and first mile, last mile with the driver community enabled model. So I think broader direction, what this panel I saw, okay, it's more relevant for us as well. So that's one thing. And in the public sector, public transport sector, whatever we observed here is, as rightly pointed out, data is will solve 90% of the problem, is what we saw. Technology is not a problem, data is a problem. Data standardization definitely needed, and there are different standards are available, but I think we have to commonly agree to one standard, then we should start somewhere, right? So that's where I'm seeing difference in different parts of the cities as well. And I think now MTC, the bus transport, the data, we almost worked for almost 6 months with the data. Now it's in a good shape that, okay, we will be able to make it open. So we are working with multiple other vendors, I mean other governments also, to bring those standards and make it openly available, will enable all the institutes also to innovate on solution. That's where we saw in Namayatri as well. We opened up all our data, business data, which is available on our website as well, namayatri.in/open. And our code is also open, because in this AI era, we are able to write a prompt and able to generate a website. So we are also getting into that. We built multiple dashboards by doing vibe coding, which is a very fancy term right now. Yeah, but it's production ready. Now I think AI is in a stage where we can leverage that. Whatever it takes months to build, we are able to build it in a minute. So the power of AI, we should definitely use it in this enabling all the mobility, I mean mobility sector as well. We are able to see that impact, and open as a direction. Making all the public data available to open is also not fully available right now. That we are doing, then it's good. I think everyone will get benefit out of it, and more innovations also will happen. More investments also will happen definitely in that. So yeah, thank you.
Thanks, Dhanidhi and panelists. I think I've asked everybody for their initial remarks. So what I'm told is, the initial remarks has led to a time overshoot, right? What I'm going to do now is, I have a few questions. I'm just going to read them out, right? And perhaps we'll follow the same kind of sequence as what we had for the initial opening remarks. And each of us will get about a minute. You can pick from the questions, right? Like a rapid fire, you can answer them briefly, or you can take one question and go more deep into it, right? So I'll read out the questions. If you want to note down, you could. Basically, when we're talking about this about the architecture for the Bharat multimodal mobility stack, right? And we're talking about Bharat here, not just one city. So what should be the different layers of the stack, right? And clearly, the different layers will need to have ownership at different levels, right? So if you talk about a particular layer that is required in the stack, who should be responsible or owning that layer, right? So that's one question that comes up. And also, who will build and who will operate? Are they going to be different entities? Is it going to be the same, right? That's a question. There's a lot of data that will be exchanged once this is created. Who owns the data? Right, that's another thought, that is required. Of course, we'll have more of this in the next panel also. And the ownership is important because when you're going to have disputes, who is going to be liable, right, for whatever is being shared? So that becomes very, very critical, right? And I think there was already a comment about how one size doesn't fit all. Like we said, it's a Bharat stack, so clearly you need to have different solutions. Again, ownership, who is going to own? Is it going to be one stack owned centrally somewhere by one organization, like say NPCI manages the UPI, right? But here, different cities may have different needs, different levels of cities will have different needs. How do we reconcile that? And also, who is the customer, right? Is it the citizen, the end user, or are the operators, right? And then, of course, the design may change depending on who the customer is, right? I think I will stop. I had a couple of more, but I think these are sufficient. And of course, not everybody has to answer everything. Maybe we will start with the same sequence. We'll start with Pravesh and we'll go on up to Dayanidhi. And then we'll also hear from Nagana-san and Abhik, their final thoughts on these aspects. Pravesh?
Sure. So I'll definitely again try to be very succinct. Let me just, ownership is a very interesting question, Geeta. I think this is the most complicated question also. I don't think protocols and stack, architecture is important as much as we think, because we believe it's very, very, even though it's Bharat, not a particular city, it will be pretty much, abstract sense, very similar. Ownership part is the most important part. I think owner should always be the government, at some level, at whatever level we are operating. And I know, again, this may be controversial, but when I say owner, I mean, they should be responsible for keeping it alive. And then, you can have academic institutions and startups and, industry. But, as soon as we say that, it goes into this tendering mechanism, which absolutely will fail everything. So we require a very, we require JICA, we require folks like JICA who are away from tendering mechanism that the government operates. I mean, I mean that's a joke, of course, but we should be owning it. We should be owning it, and it it should become like a service that cannot be stopped. So the ownership comes from that level of commitment, which has to be shown by academic institutions and government in particular. But I think folks like MInT, folks like IIIT Delhi, or we should be taking the initiative to own it, but the ultimate ownership should always be with the people, which means with the government. That is my broad answer. Now, it may not be a very palatable answer to start with, but believe me, the other part, right, where the ownership is given to a corporate that comes through a tender, is absolutely not workable. There is no doubt in my mind on that. I'll stop here.
Thanks. Manish?
Yeah, hi. So quick one. Firstly, from a stack perspective, I would say, there is the data part, and the data resides in different places. The roads ministry will, of course, have the data. The state data will be with the state institutions. So I don't think there will be a central place where data will reside. There will be different stakeholders who will, vehicle data will be the road transport department. So all of those will be within different institutions. So you do need a data policy, like the previous gentleman was saying, and I think that is a very important piece in terms of who reside. It should be clear who is the owner of what data and who is the custodian of data, right? And I think that's a very important piece of the puzzle. Second layer of the stack is the service delivery part, which is there in the diagram Nagano-san was also showing. The services that needs to get, and there will be large number of service delivery. Somebody who's giving for metro, buses, so all the services that is happening, there'll be service providers, right? And then I believe there's a third layer of the stack, which are the aggregators, and eventually you should treat them slightly differently. And so basically there's the data side, there's the service delivery side, and then there's the aggregators. And I think how data will get exchanged between each of these will essentially be defined as the protocol, right? And so that's part of it. One of the things that I think we should look back is the journey of the Indian Railways transformation. Though it's a slightly different space, but I think there's things to be learned from it. We've all been old enough, we stood in lines when we were young kids for railway tickets. I think, and how railways has fundamentally transformed. There is, of course, the railways infrastructure. Today we have IRCTC, which delivers most of the public services. So there's a split between, the fundamental splitting between infrastructure management and service delivery is what enabled, and the Rakesh Mohan Committee report is a phenomenal report that I think everybody should go back and read. It's 20 years old. Then there's, of course, IRCTC is a monopoly by itself. It should not be. You could build multiple IRCTCs as well. And then you have the Make My Trips and the guys who are aggregating services and from airlines, from transport agencies, etc. And I think that seems to have worked well. And means today we can book tickets, railway tickets from IRC from a citizen's perspective. The investments that have come into IRCTC today I think is a $7 billion company. It's sustainable. Railways own 66% of it, so a lot of money goes back to infrastructure. So I think it's a fascinating model to think through. It may not necessarily work in every cases, but I think it's something to think about.
Thanks, Manish. And that's railways, and we need multimodality. So we need to work across multiple railways, and so much more complex. Yeah, Rama. Rama, one additional question to you, right? Where is the United States when it comes to DPIs in mobility? That you could also think about.
Where is the United States? The United States is a free country where everyone does whatever they want. So there is total competition for, you'll find multiple people doing similar things in the same region, I think, or the same zip code even. I think in the US at least, communications between these vendors happens on a very ad hoc basis, depending on someone goes after the data for a particular project, and then they find someone who has something that can help on the project and then some kind of collaboration happens that way. It is very rare to see a central repository of this happen anywhere. I think that's for better or for worse, that's what happens. The only level where some level of standardization happens is, I think it's far away from this topic of AI and so on. It's in the topic of household travel census, travel surveys and so on. So every state, every planning agency always contracts out to an agent, a data collection company to do this for them. But there is also a national travel survey that is also done. So they make sure that every state is represented with a certain amount of sample size and things of that kind. So it does help when you run out of data to actually collaborate with them and take that data. That's of course freely available to them. Getting back to this list of original questions that Geeta stated up front, I wanted to again focus on who owns the data. And I think from when we're talking about stacks and so on, it's important to clearly define what we mean by this data, because what's data from a stack perspective? We want to provide data for other people to build on and leverage off of, which means it cannot just be the data that someone collected out there. It needs to go through a process. It needs to be filtered. It needs to be cleaned. It needs to be augmented, smoothed, whatever you call it. Any one of us who has worked with any data set will know that no data set works out of the box, right? It needs a lot of work done to it. So when we're talking about stacks, there needs to be some basic level of standardization on that, which means you can leverage data that comes from other people's data sets. So people can own the raw data that comes in, but anyone who collaborates with the stack is essentially in some kind of sharing mode. They give you the data, it gets cleaned, it gets standardized, it's available through a standard API so that anyone who wants to access it has access to it. If you're talking about a national stack or a national digital twin, I think it's important to do that. That anyone wants to apply it has access to the same type of data. It might come from whatever source, but once it goes through the filtering process, it kind of becomes universally recognizable and usable. And once you want to have something like that, I agree with, I forget which speaker said that, perhaps it was Dr. Pravesh, you need the government involved at some point to enforce that, right? To always be there to make sure that the data pipeline is kept flowing, that if some people turn off the taps, then other taps are switched on and so on. Quick comment about one size fits all. I think there are many stakeholders here. Not everyone is going to want the same thing out of the stack. And that's why this concept of a digital twin kind of helps, because nobody can innovate in a vacuum. There are too many moving parts in a mobility ecosystem to say, this is all I want and this is what I'm going to do. Whatever you're going to do is in addition to everything else that happens around you. So the digital twin has to be a system-wide approach, and that digital twin can be one size fits all. People take whatever they want from it. If you're trying to optimize a public transit system, you use that. If you're trying to optimize an aggregator service, you use the part of the digital twin that is relevant to you. I think that's my take on it.
Thanks. Vijay?
I agree with what Rama has said. And from my perspective, when you ask the first question, layers, right? The physical layer, the data layer, integration, application layer is how I look at it. But the most important layer that needs to be there is the governance and policy layer. Okay. So once we have this, and the ownership always has to belong with the taxpayers. Okay. I won't even use the word government. It should belong, even the private industry stuff needs to somewhere flow into the open area. So that's where it becomes everything. That's where we talk about open data policies so much more. Because without that, we are not able to, like, half our problems are the data quality, right? Even the PhDs and everything that we are doing. I look at the PhDs here, the quality is so much lower because they spend most of their time on data, okay, getting hold of the data. I was pretty happy with the IUDX platform for a while, okay, because the thought process was you get data from different sources. They're not worried about how they create it, but there is a set of people who are converting it. But then we need to have committees on that to make sure that it gets converted to the format that is everybody requires. Because Pravesh was saying, hey, they're not using GTFS, and then it's not useful, right? If they create their own formats, it's not very useful. So we got to look at like things like IUDX platforms and stuff, because At this point of time, going and talking to each government person, especially bureaucrats who change every 3 years, is next to impossible to do it. But we need to have a policy that they change the date, send the data, that any new vendor, anybody who comes in, and we have a set of people who will convert it to the formats that we need. At some point, the digital twin will be the answer, of course, but getting to the digital twin is not an easy process to get there. That's why I'm a big fan of use cases and trying to make sure how many use cases are taken care of. Because when you look at the high level, you never are getting into the details, and details is where most of the Indian projects fail. Because 5% outliers that are there, the government, like the guy from the government will point out saying that 5% is not working and says this project is a failure. Right? This is all our experiences, I'm sure. So that comes. I leave it to the next person. Yeah.
Thanks. Dhanidhi.
So yeah, I agree with sir. Actually, who will use the data, right? It should not only the government, it should be institutes, private entities, whoever wants to innovate, okay, let them take it up. But standardization and policy, as he was rightly mentioning, policies has to be set. I think TFL had open APIs also, but I think that's a static information. At least that level of data are available to everyone is good in terms of enabling everyone to innovate. That is one. And who owns data? Obviously, it will be service providers, whoever sector-wise, but it has to be open. That's the fundamental thought process should be aligned across, because keeping it closed doesn't work out. Even they won't be using it, and it's practically happening. I can see that somewhere people were mentioning, okay, we need to do route rationalizations and all those things, but they are not doing it with the data, whatever it's available. So if it is open, definitely some private players will be doing that solution, and it can be utilized by everyone as well. That is one. And I think the entire framework, right, who will build? Currently, the problem is the vendor lock-ins, and every 5 years a vendor changes, and he won't be transferring whatever he have built. So there are too much complexities, and service providers also doesn't have control over it. Okay, but so someone have to be building the fundamental framework like UPI, and everyone should adopt those, then build solution on top of it. The fundamental, if it is built, then all the top beautification can be built by anyone. Even the service provider themselves can build a tool on top of it. But the base fundamental data, basic, let's say depots, or in terms of bus, metros, ticketing, let's say, if some basic standardizations are done, it's gonna be a big boom in this entire sector. So who will build? It should be community driven. So Beam use case, the initial, the common library has been built by us, so that enabled for further development, but the fundamental has been built, standards has been set. All the banks has the protocols to implement, NPCA enforced and got the work done from all the banks. So that level of work has to be done in the mobility. Layer wise, yeah, of course, the service layer, definitely they have lot more other problems to handle than tech tech part. The tech layer has to be built in a partnership way, but it has to be partnership through institutes like Kumta, institutes like IIT. People can build that basic fundamental part. Legal layer should be there, where all the policies and legal part has to be handled, and innovation will happen by the tech itself. And once we open, I think everyone will be able to innovate, like ONDC like a model, or UPI like a model, Phone Pay, Google Pay. This kind of players are just coming into the market, and even WhatsApp we are able to do the payment. Releasing a payment app in India before UPI, it's a nightmare. No one will be able, and the experience is worse. So such innovation, such momentum has to happen on mobility. That can happen through this way of directional path, okay, open and available for everyone to take it and use it.
Thank you so much. I think we are way over time. So we go back to where we started with Nagana-san and his vision on Delhi transport stack, and I think he has been patiently hearing all the different panelists, their viewpoints. So I invite him perhaps to give a few concluding thoughts to the panel itself.
No. Well, I mean, thanks. I mean, maybe first, because your question is quite interesting. I just for 1 minute to provide my thoughts as well. I mean, regarding ownership. One, I mean, basically a little bit of repetition of what we just I have heard from the participants. But for the data part, apparently, just the federated architecture, the data ownership sits on its data owners, and whether those data actually should be completely open, or we just put digital highway for data to be interoperably connected, but not necessarily all data are open. Data can be privately exchanged on the public highway. I think there's a little bit of nuance of the differences, but the data should be sitting on the data owners. Whether data should be 100% open or the exchange is through the public infra is something to debate. And on that, the governance apparently is really important. And for the question about Bharat Stack, the governance really has to be managed by the central government of India. I think that's really important to have a uniformity for the data standardization of MInT protocol and others. But whether to have a particular DPI data exchange layer built in each city, whether that's going to be happening on each city or each jurisdictions. I think that's something that what we believe is trying to do currently for Delhi, Mumbai, and Bangalore. So that while the standardization of the governance should be maybe held by the government or central on the particular system of the infra itself can be maybe managed by its localities. Again, to me, it's echoing to the Pradesh in the government. And by the way, Delhi's transport stack is going to be held by the Delhi government. So that is our agreement that they will be owning it while Pradesh team will be running it. So that entire public transport players believe in that okay, this is kind of the ecosystem led by the authority of the government of the Delhi, so that the people will follow. So that's the DPI part to me. Framework for the government of the central, and the system itself can be owned by the government of each region. But then again, on when I say DPI, there is certainly a DPGs as well, the public goods, and infra for the data exchange, but public goods. And for that, it's quite interesting always to see the Indians ecosystem that be it IIDD or the IUDX or like a MOSIP, and those are the custodian of the DPGs. That is not public, not private. And a bunch of the tech players and having good wish are really working on that space so that how a part of the core building blocks will be complete, make an open OSS, and a DPG custodian will own it for the scalability is a really important ownership layer that has not been touched upon on the from the previous speakers. And according to services driven by both private and public, that's for sure. And so that's something regarding layer-wise ownership. That's how I frame it. Then this leads to this ownership really has to be together with the business model. How Bharat Stack or the Bharat Stack sub-stack of the each city, how the business model functions. For the government, for the government to run, for the private sector to play on top of it, and for DPG custodian to continuously being financed for their sustainability. What is the business model for every stakeholders to autonomously run for their own benefit? So having comprehensive, holistic business model which enables running for each stakeholder's business is quite important. And I personally have not found the particular one right now. And then really, this is a journey. And it's really important journey for long-term sustainability. And the last but not least, whether this stack approach actually fits for every city, particularly for the tier 2, tier 3 city, is something to think. Apparently, tier 1, tier 1 or large tier 2 cities where you have 2, 3 or more mobility, then multimodal mobility is apparently one of the key issues to solve. Then stack approach for the data standardization, data interoperability, aggregators. I think that really is a key. But with Namaya tree or ONDC FIDE, Sujit approach, it's more like a citizen-centric, not necessarily having a broader stack approach, but rather more like make every data tokenized and interoperably connected for the real-time optimizing demand supply matching. I think that is all about Namatri and ONDC. And for those a little bit small city or tier 2, tier 3, is that kind of stack approach is a panacea or not? Is something that we may think going further. And again, this is a little bit counting, but it is something, counter to what I'm doing right now, but this is something that I have already think about. But sorry that I'm take too much time for wrap, but that's my thought. Back to Gita.
Thanks a lot. I think it's quite a lot of information for us to sit back, review this again, digest, and then take this forward. I think we'll have more specific discussions in our monthly roundtables going forward to take specific issues, dive deeper, right? So with that, I thank all the panelists for taking the time on a Saturday morning and joining us, right? Both in person and online. And what we'd like to do now is I would like all of you to keep your camera on and put on your best smile, and we'll come forward as well. I request Ramki to hand over a small token of appreciation to Dayanidhi. The rest we'll send it by post to you. We'll just take a photo. After that, what we'll do is we will break for tea, and then we'll come back in 10 minutes. So, yeah, thanks. Thank you all. So we will get a tea, right? Those online, get your own tea, and then we'll come back in about 10 minutes. Thank you so much. Yeah.
Thanks, Gita.
Thank you.
Thank you, everyone.
Yeah, thank you.
So if we could settle down, we're going to be starting our next session. Thank you. So I'm sure the snacks and the tea has put us back on track, and we are now starting with the project showcase. So out of the repertoire of projects that the MInT is working on, showcase today will be the Loop project, which is a transportation solution designed to provide a visible, trackable, and flexible commuting system that encourages people to shift away from using two-wheelers and cars. Its primary goal is to reduce at least 70% of the motorized trips that begin, occur, or end within the campus. And presenting the project is Mr. Rocco, upcoming transportation expert and PhD research scholar.
Thank you so much, Dr. Kalita, for such a beautiful introduction. Good morning to all attendees who are in Eastern Hemisphere, and good evening to everyone in the Western Hemisphere. My name is Rocco. I'll be presenting one of the projects which is being undertaken by MInT Collaboratives. It's aiming at providing a sustainable mobility for our campus, and we have named the project as The Loop. Now, before I tell you about the project, let me introduce why we felt the need to do this project. As many of you will be knowing, our campus is a huge one, spanning over 2.5 square kilometers, and it's home to different varieties of flora and fauna, including human beings. The notable animals include spotted deer, black bucks, and the macaques. We have over 100 species of birds, some of which are resident, and some of which are migratory. They come here to enjoy our warm welcome and our warm winter months. And we have over 300 species of plants and trees. We have around 9,800 people living in the campus. Now, it all seems rosy and beautiful after learning the introduction of our campus, but then we started having some problem. A problem which initially started slowly, but in recent times had rapidly increased. That is the number of motorized transportation in our campus. And with the increase in number of motorized transportation, we have seen increase in noise pollution. We have seen increase in emissions from the vehicles. Also, in recent times, we have witnessed so many vehicular collisions between animals and the vehicles, and often leading, sadly, to some fatalities as well. And along with, just like any other place, the increase in motorized vehicles in the campus had led to demand for parking spaces. So the problem is we cannot take away the need for demand for mobility from the people without providing an alternative solution, because this mobility and these trips are happening for a purpose. So we came up with a solution. We aimed at reducing 70% of the motorized transport trips which are happening in the campus, which are starting, ending, and happening within the campus. And we have divided it into two different segments. First one is to introduce a new e-vehicle which will enable hop in and hop out. So the idea is the vehicle design should be such that it will be as easy as getting onto an escalator or getting out of an escalator, which will reduce the time for which the vehicle is stopping. And the second part of the solution is to introduce a vehicle routing problem. The idea is to have an optimal utilization of the resources. So that we can do by having a nice route planning, and also we will be having route assignment and vehicle assignments. And for us to be able to do this, we need data. And we had an idea, why not make that data collection smart? So first of all, for that to happen, we need to know how exactly how many trips are happening in the campus and from where to where it's happening. So we came up with, okay, let's build a smartphone application to help us collect data. And but that can be used only by people who are kind of frequently visiting the campus or who are residing in the campus. And for those who are who comes for one-day workshop or for some official work, we thought we can make use of the CCTV cameras placed in by our security section. And whichever is, if there is any labs in all those, we thought, okay, we can make use of the daily vehicle passes which are issued by the security section. With this data in our hand, we can have a study on the travel demand and the trip pattern. Trip pattern basically means from where to where and how many. With that information in our hand, we can go for the route planning. Now, as you already know, our campus is a part of a national park, and I had already explained the other residents of the campus. In fact, actually, they are the native of this place, and we are their guest. So if we are leaving them out, we can't claim the project to be sustainable. So we want to have a solution which is, inclusive of these other residents of the campus who are, if not more, equally important. So we thought, like, while doing the route planning, we will consider the animals will have some patterns of movement inside the campus. We will keep that in mind. Along with that, to bring in minimal infrastructure changes, because the e-vehicles will need some, places for charging time to time, because that's one of the major concerns of e-vehicles, range anxiety. So we can make use of that, and there is a plan. We hadn't started it yet, but there is a plan. We will be doing smart data collection for park infrastructure as well. And also we will be marking the walkways, because every trip, irrespective of how rich or poor you are, every trip starts and ends as a pedestrian. So in our campus, we know people usually use these walkways a lot. And also if there is any map which is available in our existing inventory, we will be making use of that. Now, once that route planning is done, we will be launching an app for booking trips. The user can book from where they want to board and where they want to get down. And we will couple those two together and do the route assignment. Basically, a vehicle will be assigned to that user, and we will be planning which route the vehicle will take, so that the distance traveled by that vehicle will be minimal. The number of vehicles used will be minimal, but at the same time, we will be meeting the mobility demand. So I have spoken about one app which we had developed for collecting data. I'll quickly walk you through it. You don't have to read each and everything. So basically, if it is a first-time user, they have to fill a form. In that form, I'll explain about that form later. But basically, we are collecting some socio-demographic data related to them. And that app need to have permissions for accessing location and internet, and to be able to run in background. And once installed, the app will keep reading the GPS location of that phone. If it detects any change in the GPS coordinates, it will initiate a data. And once the phone stop moving, or if there's no change in the coordinates for 15 minutes of threshold, the app will decide, okay, the trip has ended. It will prompt the user to fill in details like the trip purpose, the mode of transportation they had used, and if it was motorized, how many people were there with them in that vehicle, and so on. And so if you if you look at one of these logic box, it has crossed monuments. When we are talking about tracking people, for every second, the issue of privacy comes in. I'll explain a bit more about crossing the monument later. So for now, just do remember that. So this is the registration form which I had mentioned earlier. Some socio-demographic information like where they live, what is their age, what is their gender, what kind of job they are doing here. Those will be collected. It can be used for correlating with other travel demand and pattern analysis later. Okay, so I was talking about the monuments. So our promise to the users is, while we keep track of you, we are not going to log any of those data. We are creating some virtual monuments in and around the campus. They are all spaced 400 meters apart. So there is enough ambiguity, like say suppose if we are here and within a 400 meters, maybe even our admin building could be in the place. So there is some level of privacy which we are maintaining while we are tracking them. And please do remember this slide also, because I will be referring to it after I give a small demonstration about that app. So this virtual monuments we had, this is how it looks like when overlaid on our campus maps. We have deployed hexagonal shaped, because if you know basic geometry, it's one of the most efficient shapes when it comes to utilizing surface area. Okay, so here is a small demo of the app. We are launching it soon, and you will be using for. So like I said, it will ask for the basic permissions like being able to run in the background, being able to send notification. And the landing page itself will have the the kind of FAQs and the consent form, and the user can log in with their phones. I have tried my best to blur the user's number. Occasionally it may pop up, sorry for that. So like I said, there will be, in the registration, we'll be having a small data collection for socio-demographic profiles. And once that's done, it will take you to the landing page. You can see the hexagonal quadrants which I was speaking earlier. And once this is done, the user may forget about the app. Whenever a trip comes to an end, he or she will be notified about the trip. And during that time, he or she may, if they are being kind and free enough, they can fill it, or else they can put it to fill later, and the app will remind later again at night when they're relatively free. So this is how okay, before that, let me point out something. If you remember, I asked you to remember about those monuments. So the unique thing about this app is, the same app you can literally use anywhere in this world, be it for any campus, for a city, a town. Only thing is, if you remember, I had some set of coordinates that only you have to change. Everything else, it's universally kind of compatible, universal in this world. Okay, now this is how, this is not the real data, this we obtained while testing the app. If you can notice, the user ID had been masked. It has been replaced with some random unique identifiers. And you can see that monuments which the users had crossed are being logged. We have logged the start time, end time, and trip purpose and all those. Since it was for testing phase, the people who had been helping us in testing hadn't filled it. So the next step is we are going to be developing the app which will be used for booking the mobility solution we had been proposing to introduce. So basically that app will have, if you are already a user, so we can divide this flow into two parts, backend or front-end. Front-end is what is made visible to the users in that app interface, and backend is what we will be doing in our server. So once a user has registered it already, he or she can book trip request. She have to log in the intended place from where they will be boarding the vehicle and where they will be getting down. Once that request is placed, our system will have a go through the current locations of our vehicles, what route has been assigned to them, and how many people are there in that already, whether we can we have space to make anyone else board or not. And then by DVVRP, what I mean is dial a right vehicle routing problem. Vehicle routing problem is basically a small kind of mathematical tool we use for assigning vehicles. So I'll be a bit inhuman. I'll be treating people like a commodity at this point of time who need to be transported. So why dial a right is because we don't know the demand. It's unknown and it's dynamic. We don't know the origin and destination. For example, if a vehicle is going to travel from A to C, I don't know what demand will come on the way, in between, like at point B. And once the algorithm is executed, the vehicle will be assigned to that given user who had placed a request. And based on that, in her or his or her app, they will show the vehicle ID, which has been assigned to him or her, and estimated time when he or she will be picked up and when he or she will be dropped. And once the user board the vehicle, a trip will be initiated. And after reaching the destination, the trip will be ended from our side. Now, while doing all this, we will be having a kind of feedback loop where we will keep collecting data of which vehicle has been assigned to whom, so that we can keep a track of the data which is required for executing that vehicle routing problem. Now, currently, we had developed the app which is used for data collection. Maybe in next week, it will be up and running in Play Store. I'll take this opportunity to appeal to everyone. Please adopt it. We are not going to interfere with your privacy. It's for everyone's good, including the native resident of this place. The next steps is parallelly we will be doing the data collection, and we will start brainstorming on formulating the vehicle routing problem. And parallelly, we will be developing the app to speed up the project execution. And now that, straight translation from mathematics to real world application sometimes can be catastrophic. Sometimes it can be costly in terms of time, resources, finance. So before doing that, with the data collected and the vehicle routing problem we had formulated, we will be running some agent-based simulations. With the learning from the simulations and with the booking app, we will couple them up together and we will get this alternative mobility solution, which will be implemented in real life. Thank you so much for a patient hearing. Do we have time for questions?
No.
No, okay. Thank you so much.
Thank you, Rokam. A much needed solution for the campus, and I think a very different perspective on who residents are and its inclusivity, right? So thank you. Next up, we have the D squared panel. Any guesses on what this D squared was? So I'm back to my in-person test or quiz. Yes, data and digital twin. As we just heard from the previous sessions, data is at the core of any technology. So let's look at what is the common link between data and digital twin in this panel. And to moderate the panel, I invite Dr. Ramki, CEO MInT, onto the dais. I'm also going to be inviting the various panelists who are joining us online and in person. So we have with us Mr. Asad, Director General Department of Telecommunications, Mr. Satish, Joint Director Center for Development of Advanced Computing, Dr. Subramani, Vice President UPS India. Please come to the dais, sir. Welcome. Mr. Aditya, Principal Decarbonization Consultant, Arup, and Mr. Jay Kumar, Member Secretary, Kumta. So there's also a small change. Mr. Jay Kumar could not join us in person here because of his personal commitments, and on his behalf, we have Mr. Vignesh, Data Architect, Kumta, who's also part of Mr. Jay Kumar's team. Welcome.
Hearty welcome to everybody. It's a real privilege to moderate this panel where we are going to be I believe talking about the problems at the crux of mobility in terms of data. And I think in the last panel, we had a very lively discussion on lots of aspects touching data ownership, so on and so forth, right? So we'll explore a little bit more of that, okay? Now, given the constraints of time, we are going to have a fairly methodical way in which we are going to do this. I have been looking at the themes that we need to explore, and there are 3 themes, and we will be devoting about 10 minutes to each of them. And if we have any time beyond that, we will have a little bit of exposition in terms of Q&A, okay? So let's dive straight into it. And I'll kind of pose the theme, and I will request a couple of our panelists to give their comments relative to that, okay? So first, we'll start with, let me actually tell you the themes so that it gives you a little bit of time to think about it as well. We have this digital twins, which are digital models, right? So these models are built at various levels and layers, right? And you could have components down to, say, a signal can be a component, and then it is slowly built up over time to maybe a digital twin for the whole city, right? So it is something that gets layered up. So how does that work? Why do we need all of those things? Those would be topics to explore, right? The second part is data, right? Where is the data coming from? And are people who own the data ready to share the data? And if it is going to be shared, what are the protocols associated with that? And what is the security associated with that? So I think that's the second theme we're going to explore. And there's a third part which is related to solutions. How are we using all of this to actually build solutions? And what would be the role of AI in all of these aspects? How to collect the data, how to use the data, and how do we actually derive the models from the data or use AI in that respect. So those are the themes that I think I would like to explore. And of course, if something comes up, the panelists are more than welcome to share some very unique thoughts associated with that. So I want to kind of start the panel discussion, talking to, asking Vignesh from Kunkta to kind of kick us off, okay? And this is about digital twins, right? And we have a digital Chennai project being initiated by Kumta, right? So what is the vision of this digital twin that you're thinking about? And what are the layers you're thinking about? So could you give us your thoughts on what a digital twin means in the context of mobility?
So in Digital Chennai, what we are planning basically is two broad aspects. First one is the data exchange at the city level between multiple departments, government to government departments. And the second one would be an integrated project planning and management tool. So these are the two key aspects which we see through the government lens, which will be key for the government operations. And in terms of mobility, I think there are like bits and pieces of multiple projects going on in Chennai, like Chennai ITS, and there is parking, then there is traffic management by GCTP. So there are like bunch of projects which are going on, and to be honest, like it's very difficult to integrate multiple projects into one platform, and I think that's where the challenges which you discussed, like need for data standardization and other things is required.
So the digital twin model for the city of Chennai, from a mobility perspective, obviously is being built to kind of enable some understanding of the problems and then do some simulations, I assume.
Yes. So, so as Kumta, our primary mandate is basically for transport planning, for a larger horizon. So the first thing what we see is like the tool should support us in transport planning for the next 20-25 years. So that is one key aspect. And though we do it offline, like we do primary surveys to collect data, rely on secondary sources from various departments, that becomes a one-time activity. Whereas where I see as a digital twin is, it can help us in doing this planning real time. Let's say planning every month, every 6 months. It need not be just like a 5-year activity which is done every 5 years. The world keeps changing a lot, and you don't have a dynamic feedback. So I think that is one key component of having a real-time feedback for transport planning. The second one is identifying strategic infrastructure planning, where you need to have, let's say, depots or multimodal locations. These kind of locations to identify them. I think that would be second one. Third thing is like day-to-day operations, traffic management, congestion management. That is one key aspect, and also I think transportation is very tightly coupled to the land use. So you need to monitor urbanization that's happening across the city in multiple places. So how do you use drone or other data acquisition platforms to collect data on urbanization is also one key aspect of it.
All right, thank you, Vignesh. So let us just get a slightly different perspective and some work that's been done. I'm going to turn to Aditya from UK Pact, right? So the UK Pact has been kind of spearheading an understanding around use of digital twins for planning here in Tamil Nadu with Tuticorin, all right? Tuticorin, which is a port city, right? What should be the plan associated with that? But maybe Aditya, you can kind of throw some light on why did UK Pact kind of think about this? And are there other examples around the world where digital twins have been used in the context of mobility, right? I think that will give us some perspective.
Yeah, no, happy. Thank you very much, Professor. Really appreciate being here and sharing some of the thoughts on PACT. So I think with PACT, so UK PACT stands for Partnering for Accelerating Climate Transitions. It's a Foreign Office program that we're working with a number of partners, including Professor Geeta Mehta, IIT Madras and his team. For us, it's focused on tier 2 and tier 3 cities. So, we're doing work in Tuticorin with Professor Geeta Krishnan and also in Erode. And the motivation behind it is sort of threefold, right? It's using data to make better decisions about, like the earlier panelist said, about land use planning. Where are the trips originating? Where are they finishing? What are they doing? So if I take the Thoothukudi example, it's a port city, lots of trucks entering and leaving the city on a daily basis. If you have a real good understanding from where is the data, where are they coming from, where are they going to, what are the origin destination things, and you can do that in real time using a digital twin to map that process, that really sort of facilitates the administration and other stakeholders to understand what the problems are, areas are, doing hotspot analysis, all that sort of stuff. And then also testing out sort of solutions more quickly, right? And getting feedback on that. So it's not just about, you identify your hotspot, you sort of look at the solutions that you could potentially do. They might be hyper-local, they might be macro scale. And then you can sort of pivot very quickly. And we're hoping through this program to build some of that foundation in terms of the data that can be collected, that should be collected, and trying to approach it more from a sort of problem-focused lens. So what is the problem that's being tried to solve? Because PACT is focused on climate resilient development. But how do you use data to enable that while also enabling faster and more efficient data decision-making, right? And the other example, very quickly, I'll talk about digital twins, is what we did in the UK with the Department for Transport, trying to quantify some of the economic benefits that sort of arise from if you have a digital twin of your transport system, what are the economic benefits that you would get, and trying to quantify some of those. And from an individual perspective, in looking at the different layers of benefits of a digital twin, from an individual's perspective, the biggest savings is sort of savings in journey time. So, you're optimizing your journey times because you have a network-wide visibility across all modes of transport. You can really optimize, where are the challenges, where are the congestion spots, and you can automatically, the network can react in more real time. So those are sort of some of the biggest benefits that we see, and we would like to see that here in India and trying to build some of that at the lower level, in the smaller cities, which are growing fast, but don't really have access to that level of sort of, skill and capability that exists there. So.
Wonderful. Yeah, thanks, Aditya. Now, the comments that you made lead us to another aspect that we need to kind of explore and answer, right? So I want to turn to Mr. Satish from CDAC, right? I think being an expert on computing and to advanced computing, I have a couple of questions where you could probably shed some light relative to building these digital twins, especially when you think about intelligent mobility and intelligent transport systems modeling, right? What are the layers, right? How do we actually kind of construct a digital twin? That is, what strategies you'd use? Is this a rule-based kind of digital twin that we would model? Or is it something that is sourced from the data itself? What are your thoughts on what is the best way to build these types of digital twin models?
Yeah, good morning, everybody. So myself, Satish, I am heading the ITS group in CDAC. And as you know, CDAC is a R&D organization under the Ministry of Electronics and IT. And we have initiated many new projects in mobility sector, so particularly on traffic management. So to answer your question, actually when we talk about digital twin, it will not digital twin alone cannot go ahead. So we need data, we need simulators, and this data, digital twin and simulator will go hand in hand for any sector that matter, not only for mobility, for any sector. So we need the digital twin platform to create the infrastructure. So suppose when we talk about mobility, it is the roads and the other infrastructure that are available on the road. So all the road layout has to be marked, the different parking zones, the signal systems has to play, all the commercial malls and all those things, how it is going to affect the traffic. So all those things will come upon as part of the digital twin platform. And it has to be, so digital twin has to handhold the simulators as well. So that is another part to evaluate by various scenarios, what if happens, what if scenarios. And in order to evaluate those things, we need historic data as well as time series data, because today we see a lot of sensors are being rolled out in the field as part of smart cities. So how are we going to utilize those real-time time series data? So I think there we need the digital twin platform and the simulator platform taking in the time series data to have the real-time simulation, as well as we can have the historic data to do what kind of impact it has created, and then based on those learnings we can apply AI and other predictive analysis on this on the simulation platform. So different models can also be evolved as part of the simulation, and then we can run those models, and then we can try to refine the traffic situations or whatever parameters we are trying to evaluate using the simulation platform. And when we evaluate, the digital twin helps us to bring in interaction with other infrastructure or whatever interaction we want to make, I think, between two objects. So those kind of things we can make it possible on digital twin simulator and the data coming together. So I think we need not talk about mobility alone. It can be for any sector, industry sector or whatever it is. So that's the initial response to your question.
No, that was a magnificent and a very appropriate response. You know, we cannot separate the data and the digital twin. I mean, the digital twin at the end is a is a digital representation of what's in the physical world, right? And how do
Virtual
we?
replica of whatever it is. Virtual replica of whatever we think about, we want to evaluate something.
Sure. So when you, Satish, when we think about it, the city, for example, Chennai, is such a complex city. There's, I don't even know how many thousands of kilometers of roads, how many traffic signals you have. I'm sure that we have a lot of sensors monitoring different things, not all this of the same quality and of the same standard, right? So when we build this virtual replica for the city of Chennai, do you think standards and do you think there should be a level of understanding how the units should be actually developed? That's one part of the question. The second part is, okay, when you look at it, how do we actually use the standards to actually derive or use the data to derive the units? I mean, it's two ways, right? So can you elaborate some thoughts from a modern computing perspective?
No, I think we cannot stand away from standards. So unless standards are there, interoperability may not be possible. So standards and open APIs are part and parcel of any platform that we develop. So in case of mobility, if you particularly say, once we want to have, because our main objective is to have some kind of Bharat mobility stack. So once the stack is available, tomorrow there will be n number of applications that will be rolled out. So this stack or this platform should be able to plug in and plug out any kind of new services that is coming out of the that is coming into the ecosystem. Because if you see, micro mobility plays a major role in this, and there are many startups and private companies and many organizations having their own apps. So we cannot avoid when it comes to micro mobility. So we need to add on those kind of services. If we want to add, then we should be having some kind of standard. Suppose it is for whether it is GTFS for any static data or GTFS for RT for any real-time data that we are looking at, or if you want to have a micromobility this thing coming into it, then we should have MDS. So that is mobility specifications. So we cannot stand away with standards. So standards are the most important part, and the protocols at which they communicate, that's also very important. So I think we should, whether we roll out Bharat mobility or not, but we should come up with the standards first so that everybody hooks on to that, or everybody starts developing, everybody in the ecosystem starts developing using those standards so that it is very easy for the rollout.
No, thank you, and I think it's we are on a great point with not only the city of Chennai developing this, and you have this work around what UK Pact is kind of helping us think through. Maybe as part of it, we kind of look at the standards that are required. Let us just switch our thinking a little bit. We, of course, have talked, as we talked about digital twins, about data, right? Now, the question is, we have a whole bunch of sensors that are available where we can get some data. What best than a mobile phone in somebody's hand, right? So today we have Mr. Asit Karayan from the Department of Telecommunications with us. And, you know, I think I would love to hear from you how the data that's available, it's a big bank of data, how that type of data can be made available. How can it be used for thinking about solutions around, for instance, mobility?
Yeah. So good afternoon. And thank you very much. And it's a privilege to be part of this conference. Am I audible?
Yes, you are. Thank you.
Yeah. So, as far as digital twin is concerned, there are three parts. One is that what exists today. Second is that what is happening at the moment. And third is that what if some intervention is done, then what will be the consequences, what will be the changes. So this telecom network plays role in all the three layers. As convergence is happening, so telecom is getting converged with the computation, and it is in the 6G, it will be converging with the sensing systems and LiDAR and other kinds of sensing systems only. So it is not only a IoT and M2M stuff to capture the data, but it will be helping to create the digital twin, geospatial digital twin. It will be helping to render the digital twins, and it will be helping to refresh the digital twins on a frequent basis. So in this entire life cycle of the digital twin, telecom network will be playing a big role. And the question and the beauty of mobility data, which you have mentioned, is that you have a clear picture of the mobility from door to door. Door-to-door mobility. So even if you are changing the mode of the transport or you are doing a lot of stuff, you can stitch them together because you have an entire picture of the mobility of the people. So you start seeing from the people's perspective, citizens' perspective, and this in this process, what you ask, what is your question, that if data is available, how we can utilize it. We have examined, and there are a couple of issues when you want to access the data. Means many initiatives have been taken, like open data initiative or a data exchange platforms. But whenever you will look at the data, you will not get a complete data. You will not get the best quality data. What are the reasons? There are two primary reasons. That how to take care of the privacy concerns, and not only privacy concerns, commercial sensitive data related concerns as well. And second is that what are the incentives? So whenever we are talking of the data availability or data accessibility, we have to consider these two aspects. And in the privacy, usually people jump that anonymization or aggregation is the answer. But it is only a partial answer. It is not totally effective. So you have to consider the privacy enhancing technologies which are available today, and how the communication networks will be helping to achieve privacy by design. Privacy by design means it is not a single technique, single method. Even the solution architecture also matters when you want to preserve the privacy and you want to respect the privacy. And in an incentive framework as well, the issue is that it's very difficult to price the data because nobody knows the value of the data in the beginning. Data seller or a data user, it is a peer-to-peer relationship, and how much you can extract out of this data on the basis of that data value depends. And data value also depends upon the combinatorial value of the data. Means it is not only a single data which matters when you have to combine with the other kinds of data and what value you can extract. So we have to solve with the problem of the privacy by design, and it is not limited to the anonymization or aggregation. And we have to create an incentive framework that people are not forced to share their data, or we are not persuading them to share the data. They are excited, they are willing, they are interested, and they are trying to provide their best. They are not limiting themselves to the compliance of some regulations or compliance to the requirements. They should offer their best. They should try to enrich the data. They should try to improve the quality of the data. How that framework is created, and DOT has recently created a special unit, which is a digital twin unit, and I am heading that. And it has launched a Sangam Digital Twin initiative, which is aiming to achieve what I have described. That how we will be participating and how we will be helping all other cities or national level to make that data accessible and available in a manner that it is privacy preserving and it is incentive aligned, and we are continually get the best out of best intelligence out of this data.
Wow, Mr. Asit, this was a wonderful exposition of what or how should digital twins be conceived and how data kind of should be looked at in the context, right? And I'm sure from MInT we are going to be very excited to kind of and are waiting to work with you on some of these aspects. I do have a couple of questions to you, but before we come back to those questions, I do want to pose a question that you alluded to in terms of the incentive. How do you price the data and what is the economic value of it, right? So today we have with us Dr. Subramani Ramakrishnan from UPS, right? And maybe you can give first a little bit of a sense of how you view the digital universe, because you are engaged in the business of mobility. You're moving packages, God knows how many millions every day, okay? And how do you build your network, and what type of data are you looking for to help you with that?
Sure. First of all, thank you for this opportunity, and let me set the context for how we use data and digital twin at UPS. So UPS is United Parcel Service. A bit of context setting: we move about 6 billion parcels a year, about 20 millions every day. 20 million parcels every day across 200 plus countries and territories. And just to give the magnitude of the operations, in terms of value, it's about 2% of world's GDP every day, right? So that's the kind of business impact, as logistics operators that we create. And we have about 600 flights, our own chartered flights, and about 150,000 trucks, and in all about 500,000 people who are working behind the scenes to move these packages. This includes the drivers, this includes the loaders and all of that. So how we use this data, because we get huge amount of data. Every day we get about 1 billion pieces of information, because every scan is literally a data for us, right? And every time a package moves through our network, that's a piece of data. So what we do is, we kind of use this in one planning phase, right? Every day 20 million parcels are going to be delivered by UPS, but God knows who is going to send what, right? So that's the challenge that we have, because when you look at this packages of 20 million, 70% of the packages leave are delivered within 2 days, right? So that is one. And then what we call as manifest, the reliability index of that data is not all that great. For example, as a customer, I may decide that I'm moving this, or I'm dropping this parcel which needs to go from point A to point B. And the first time I get to know is when they print a label. They print a label on their computer or their mobile app. That's when I get to know that, okay, this person is going to do from A to B. But I don't know when you will drop it. Probably you're going to drop it today, tomorrow, or day after. I don't know. right? And then you may say that you will drop it at place A, which could be one of the drop-off locations, or you may ask for somebody to come and pick up, or you may drop it in a UPS store or whatever. So I really don't know what's the induction point of that package in my network. So this is where, we do 3 levels of planning, and we exactly have this whole network. What we call as, there are 3 systems that we have developed. One is what we call as a network planning tool. The network planning tool kind of looks at all the historical data, the specific customer, because we also have these enterprise customers where we have a fairly good amount of data, and which are fairly having a good amount of accuracy, right? And then when you look at our operations, it's technology as the heart of it, wherein in our sort location, where all these packages come in and they get sorted, the sort facility sorts about, 500,000 packages within 2 hours or so. That's the sort window within which we need to sort, and all the inbound parcels go to the outbound trucks that are parked out there to the respective conveyor belts within 2 hours, and the package is touched by humans only twice, just to unload and put it on the conveyor belt, and then to take it out to the outbound traffic, right? So we have this, conveyor belts that run for miles together within the sorting station. So that's where, it becomes very important for us to say, in this sorting hub, how many parcels are going to arrive and how many parcels are going to leave and to what destination, so that we exactly plan how many drivers we need, how many trucks we need, etc., etc. So that is sort level planning that we do. The second is how many devices, what we call as ULD. ULD is nothing but a feeder truck or a package truck or whatever, how many trucks we need. And then how do we do the routes, right? So just to give a magnitude of this, 1 mile saved for a driver yields saving of about, to the tune of about $50 million a year. Given, because it's all a scale thing, right? So we have a system called Orion. So the first is the NPT system, network planning system, which exactly mimics all our sort hubs that we have. We have about 2,000 facilities, so we know what the facilities are. And then, which is more planning, right? Which is looking at 1 to 3 months horizon and all of that. Then there is HEAT, which we use, which is a harmonized enterprise analytics tool, which is real time. So which is real time because we also look at the weather data and other stuff, right? So when you have 700 flights on the air, and when you have all this, in fact, the HEAT, the digital twin that we have was tested severely when we had in 2021 a severe hurricane which impacted Texas and other thing, and close to 10 million people in the US went without power. And that's when, the what if scenarios and how do we route these packages, through alternate routes and keep the network going, right? So there, this harmonized enterprise analytics tool come in, which gets continuous feed of real-time data, where the package is, and all of that. And the third is what we call as Orion. Orion is basically an on-road integrated optimization and navigation system. Much before Google came with their maps, we have our drivers with their maps. In fact, our routing is so tuned. For example, there won't be any left turn, because for a left turn, probably the driver has to wait for the signal, and there is a wait time, right? So to minimize the wait time, so we have this algorithms built in which kind of continuously tunes in, and every 3 minutes we kind of optimize these routes. Around 80,000 to 90,000 routes are being looked at every 3 minutes with all the data that we have. So this is how we use data and this digital twin that we have in UPS, which is 1 for planning, 2 for real-time monitoring of all our facilities, which is the HEAT, and the third, the on-road system that we have for the drivers. In fact, that data, interestingly, also feeds to our customer service agents. We get about 700 million hits to our website, every day. People are just interested where their package is, right? So today, the best answer you get is probably it is out for delivery. But you really don't know. At best, you may say, okay, they may come between 6 o'clock to 9 o'clock, they may come and deliver, right? But we can say when a customer service agent gets a call, oh, you know what? It's 6 hops away or 6 stops away from, from your address. Because we have this real-time data that comes through our on-road system, which is also visible to our customer service desks, so that we have that enhanced customer service experience that we can give with this data. So that's how broadly we use data in UPS.
So, no, that was exciting to understand how you organize your operations. So when, have you tried in UPS to put a value on the data? I know it is the lifeblood of your organization, and there are other sources of data, for example, the weather data that you're kind of getting, or even the signal data. How are you sourcing that data, and what value do you place on those?
Not sure how, I'm not sure if I have the answer for that, but however, most of the data that we are using today are all, from our own systems that we are getting. But however, there are some interesting use cases now we are working on. One of that is looking at the fuel prices in various states and because they're different, vendors or gas stations have different prices, right? And then see where this guy is and what the fuel level is, and then see if we can kind of recommend the driver to kind of refuel wherever it's the optimal cost. That is one use case that we are looking at. But we have more data on the savings part of it, how we have used data and how we have realized savings, but the price of data per se, I don't think I have an immediate answer.
Okay, wonderful, wonderful. Okay, I can understand that, right? I'm being told that we are running out of time. Okay, however, I do have one other layer for this panel. So we talked about digital twins. We talked about data, how to source data, and how to use data to create models and so on, right? Given this summit's theme is about use of AI in mobility, there must be a case for using AI in terms of creating usable data, right? So I want to turn to Satish and to Mr. Asit on what really are you looking at in terms of AI when you deal with big data, and how do we curate the data? Any thoughts on those fronts? Maybe Satish, you can go first. Sorry, Satish, we can't hear you.
Yes, so I was on mute. So basically, we can use AI and predictive analysis for predicting the transport demand. That is one major thing in mobility. What we can see, transport demand under various conditions, under peak load, under peak conditions of traffic, or under normal traffic conditions. So these things we can simulate, and also we can also look at AI-based predictions for what-if scenarios for any incident management, or if some cricket match or something is going on in some area in and around, then how do we route the traffic in such cases, and what is the effect on those corridors? So these are the different kind of things what I initially feel that on using of AI and predictive analysis as far as public transport is concerned.
All right. Okay. No, thank you for that answer. How about any thoughts from you, Mr. Asit?
I think telecom mobility data will play a big role in this mobility planning. And that is not being utilized as of now, especially in the India. And the big challenge was that privacy, wall of privacy. And we have recently conducted a proof of concept with Delhi Metro and successfully validated our origination destination matrix model generated through telecom mobility data. And we could also we have not only created a OD matrix with the telecom mobility data, but we could also identify the transport mode used by the person through the telecom mobility data. And we could also identify the catchment area of individual metro stations with the actual data. Time arrival distribution graph the person takes to reach to the metro station, and what are the issues which can be intervened, and we can improvise the time to reach to the metro stations, and we can see the effect just before the intervention and just after the intervention. And we have also identified from the telecom data that how much time it takes to switch from one metro line to the another metro line. So that switching time, access time, their distribution, and we can identify the specific intervention which is required. And when we combine with the geospatial digital twin on the origination side and the destination side, we can understand the context, we can understand the impedances and the inconveniences which can be codified as a part of the solution. And you can see the utility value of new intervention which you are planning in a digital twin. That can be done. So it is important to develop the interdisciplinary competencies. Means telecom people should know more about the transportation problems. It is not that only a transportation model experts can be fed with the data, telecom data. Both the sides, some competencies required to be evolved. So telecom data, how telecom data can be exposed to the developers. For that purpose, we are working on the synthetic data. And when we will be offering a synthetic data, all startups and developing community can do some experimentations and build some models without compromising the privacy. So that is our approach in the Sangam Digital Twin Initiative. And it will be quite useful. But immediately, telecom mobility data can be utilized. And we have created that framework that for immediate benefits and short-term benefits, something can be done. And for some measures, it will take some time, maybe 1 year time or 2 years time for taking more benefits from the telecom mobility data.
Thank you, Mr. Sith. I think I want to thank each and every one of you in this panel. I think this discussion, those are very short. We have lots more to explore, and we'll do that in future roundtables. There are a bunch of questions that have come in as well, and we are recording those questions. And I'm inclined to invite all of you back to a roundtable. We do this on a monthly basis, where we will explore that. What are the protocols? What are the other issues associated with this? What are the standards to which digital twins have to be built? We'll explore those things. I think it's important to get that right as part of the MInT initiative in building the Bharat mobility stack, right? I do want to thank all of you and appreciate your thoughts and sharing of your ideas on building digital twins to look at solving problems in mobility. Thank you. And I believe we do have something that we want to share with our panelists today. And I think the people who are online probably will be, we will send it to you, okay, here, because you're not here physically present. But maybe Professor Geeta Krishnan, can you please...
if you could come in front, please. Yeah, please remain online. We will be taking a photo. Can you all just face the camera? We'll have a pic of all the panelists, both online and offline, together. Thank you. Certainly interesting insights, and on behalf of the MInT Collaborative, I thank each one of you for having accepted our invitation and coming online and offline to present your thoughts for this panel discussion.
Thank
you. Thank you, Dr. Ramki. So the last panel discussion for the day is the session on AI use cases, particularly pertaining to safety, freight, and air mobility. To moderate this panel, I invite online Mr. Krishnan Narayanan, co-founder and president, Itihasa Research and Digital. Panelist, Mr. Naveen Chopra, visionary leader in automotive product development, Sun Mobility. Dr. Mahesh Krishnamurthy, co-founder Vayu Robotics. And joining us in person is Mr. Gopal Raman, ex-president Hinduja Group. Professor Chandrasekhar from the DSAI IITM ecosystem, and Professor Geeta Krishnan from DSAI IITM. And Manish as well. Professor Chandru? He is coming online. Online, all right. Yeah. So we have our moderator and Professor Chandru online. Over to you, sir.
We also have Naveen, Mr. Naveen Chopra.
He will be joining shortly.
I'm there.
He's
Hello?
joining shortly.
Can you hear me? Yeah, he's online now. He's online now. I see him online. If you can, it says administrator.
I think the name may be...
Yeah. It says administrator. If you can pin that, yes, that is good.
What about Mahesh? Mahesh will join in a minute, yeah.
And Geeta, just for because I'm not able to see the stage there.
Can you also spotlight the stage? Yes, it will come up in a second, yeah.
Okay.
Yeah.
Richa, is Mr. Manish online as well? You should also pin him to the stage because I think he'll join the panel as well.
So I see Geeta and that's Mr. Gopal Raman.
Yes.
Okay. So we are waiting for Manish to join in, I think.
I think we can get started. I think they'll join in shortly, yeah. We can get started with...
Okay,
yeah.
Okay, excellent. So I know this is the last session before lunch, perhaps, Geeta. So we'll try to keep this...
There is one more presentation, so project...
Oh, there is a presentation. Okay, good. Then we don't have any pressure, folks.
I will take all the blame, yeah.
Yeah, so welcome everybody. My name is Krishnan. I'm delighted. I'm thankful to Professor Geeta Krishnan and Ramki for inviting me to be a part of this event. I remember about a year back when the MInT collaborative was getting set up. They had invited me and I was able to participate in it. So it's really fantastic, and I congratulate the entire team for the first year anniversary. This is a very important session. I'm sorry I could not join in person. I'm sort of traveling, this thing. So here is the, I was just reading today, coincidentally, the latest Stanford HAI AI Index report. And one of the things it highlighted was the sort of the use cases in mobility, and it gave the example of Waymo providing more than 150,000 autonomous rides each week, and it talked about Baidu's Apollo Go robo-taxi fleet services operating in several cities in China. Then I also was looking at some other reports, and I see from an India perspective, the sort of logistics sector to the faces a 14% cost to GDP ratio, which is one of the highest in the world. So in a way, there seems to be, I mean, and this is probably a place where AI solutions for fleet optimizations, etc., could become could come in. So there seems to be a number of different use cases where AI could be helpful. Of course, safety is another huge area in all of this. So, and I think we have a panel here that's cutting across a very wide spectrum of topics. So maybe what we will do is I'll go to each person. I'll request them to give a little bit background about what they do, very brief background about what they do, given this area. And I'll just follow up with maybe one question to them, and then I'll go to the next panelists. I hope this model works. So we'll start first with Mr. Gopal Raman.
Yeah, a bit of introduction.
Mr. Gopal, if you can just share a little bit. I know you've done some works in automotive, defense, renewable sector. So if you can just talk a little bit about the use of AI in these places.
See, let me start with a very light note. Artificial has two dictionary meanings. One is man-made, the second is a fake. Okay, so today we have use cases from both extreme ends of spectrums. But let's not talk about the fake ones, because we have to be very careful that we only use the right ones. So if I have a choice, I would expand AI as a automated intelligence rather than artificial intelligence. So it has to start with a natural intelligence, what people have been doing over a period of time, and we automate it. We make it faster, more efficient. That's the way I look at it. So I certainly think there is a big use case in terms of public safety on transportation. That's something which I've been toying with. I've been thinking about it. And some of the panelists and others in the MInT, I've already been talking about that to them. And see, today in safety, yeah, we won't go around. Today in safety, the car companies are investing and making all the features available in the car. So whom do they protect? They protect the occupant and the driver. So the guy who drives the most expensive car with all the safety systems, he doesn't die. But who dies? The pedestrians, two-wheelers, other people. So what are we talking about safety here? That's the first question there. So the guy who has the money can save himself, but the guy who doesn't have the money is open. That's the point number one. Point number two, the cause of accident, I would put them into 4 broad buckets. And all accidents happen as an interplay of these 4 buckets, nothing more. First is the driver behavior. So this is where the natural intelligence comes in. Drivers are always having a natural intelligence, but at times the intelligence slows down, becomes a problem, various reasons. The second is the vehicle conditions. The good driver can understand the vehicle condition, but sometimes he tends to ignore, sometimes situations, vehicle fails. The third is the road condition, whether it's a design of a road or how it works. The fourth is the operating condition, which like a speed of the vehicle or a load of the vehicle, whatever you call it over there. So today, I think it's absolutely possible for us to collect data to understand and clearly define what each of these 4 conditions, what is the contribution to a safety risk. So it is absolutely possible that once we understand these 4 things, it doesn't need a lot of sensors to do that. It's very simple because today's vehicles are equipped with a lot of things. So once you analyze the data, you can come back and warn the driver on a contextual basis. This is where the difference comes in over there. If I go and tell the driver the speed limit is 60, I have a problem because the road is not continuously safe at 60. There are places where it's a 30, there are places it's 20, there are places it's 60, there are places it's 80. But we have one board. So the guy doesn't know what is the real speed limit here. And the speed limit is not determined by the condition of the road, whether it's a potholes or whether it's a slippery road or slopes. So everything has to be given on a contextual basis. This is where the AI comes in to play. So my thinking is that if you are able to get this as a part of public digital infrastructure, it's possible to collect all the data which others will share. So if I'm driving a vehicle, so I will be able to collect data which I share, give it to public domain, which others are going to get benefited of it. Now, Will the money be spent by the government? The answer is yeah, very difficult. And will everyone join? It's difficult. So look at the second one. How can we make it very attractive? The way to make it attractive is like how in life insurance there is something called a life table. So in every life insurance company follow the same table. In India, you know what is the probability of anyone at the age of 61 dying in the next 1 year. And within that, there are 3-4 categories. If he is a smoker, what is the probability? If he has got a prior medical condition, what is the probability? So these are 3, 4, 5 things which are all built in. So the premiums are all based on these. And someone wants to give the insurance or not. So how about creating a system where all these are brought in together into one platform, and then insurance company can determine the insurance premium based on the risk, whether it's the risk of the route, the risk of the driver, risk of the vehicle, and any other factors which may come in to play. And today, the second issue in insurance is the vehicle insurance is, there are 2 vehicle insurances here, okay? One is the insurance on vehicles for the own damage. Second is the insurance for freight. The guy who books the vehicle pays for the insurance, right? Now, he pays the same amount of money, whether he is going to book it through a freight company which is having good vehicles, good transportation, everything, or otherwise. So can we not link it up together that if you are able to put your goods in a 5-star rated transport system, the lower risk, you get a better pricing. If you are able to, and so that 5-star rated fellow can ask for higher freight charges, but lower insurance will be applicable there. So this is a thought I had about how do we really put it all together so that it's a safe for people to walk in the street or ride in the street. At the same time, there is also a financial incentive on how it can be funded. That's the thought I had. Thanks.
Thank you. And there's some very interesting points you've raised. But I just want to pick on one of them and just probe a little further, which is I think in some sense you were talking about, it's nice to think about the safety of the entire ecosystem, not just the passenger car in that sense. Which in some sense, I would say an autonomous vehicle is in a better position to make such calculations rather than a human. I mean, what do you think?
See, I want to be a little practical here. In India, it's going to be, in my lifetime, I'm not going to see autonomous vehicles more than 10% of them in the road. Okay? So don't mix up what is called a technology as cutting edge and what is in majority over there. So today, a life of vehicle on the road is 15 years. So if you are going to sell, let's say in 5 years from today, you're going to sell 2% autonomous vehicles. So it'll take after 15th year, see what the percentage are going to be there. It's as simple as that. So we have to work on something which is a retrofit on what we already have today. So go back and put in something which is a plug-in to something what already what are the kind of technology which has been there for the last 10 years. So the next generation of thinking will happen after 15 years. Once autonomous vehicles comes over there, we don't know. Still, that is a monster we don't know. And I will not be surprised if one day we realize autonomous vehicles are not going to work and we pull back. So that's also a possibility, maybe 10%. Because it's about the network. You know, when you have 10% autonomous vehicles, they do very well. If you have 90% autonomous vehicle, what do they do? Will it be chaos? Could be. I don't know.
Okay, that's a good thought. And I think this is where I want to bring in next Mahesh. Given his he being the co-founder of Vayu Robotics and perhaps operating at the other end of the spectrum on autonomous vehicles and entities. Yeah, Mahesh, why don't you share a little bit about what you do and where you weigh in on this?
Yeah. Thanks a lot for organizing this. So my background is in physics and optoelectronics. I did my PhD in optoelectronics and then started working at Intel Labs, then went to Apple's special projects group for around 8 to 9 years, and then worked at Lyft's autonomous vehicles team. And now my startup is building delivery robots powered by latest AI technologies. And we build both sensing and mobility applications using latest neural networks. And we use planoptic sensing for are robots, and we use neural networks for path planning. So one thing I would like to say is, having worked in this field for maybe a long time and seen how the trajectory has been, every year the rate of progress has been very non-linear. And 2 years back, we couldn't see a lot of Waymos near our neighborhood doing rides. Today, we are able to witness it. So the rate of change in the society about autonomous vehicles has been really, really positive. So what we do here is we use a similar technology, but we build delivery robots to move goods from point A to B. And we wanted it to be a very safe start. So long time back when we started, we wanted to be very ambitious, put people inside these, and move it from point A to B. And then we learned more about the challenges of this technology. So our company decided to pick a problem where it's inherently safe by design. So basically, the momentum of the robot that we have is like a bicyclist. And that's where we got our inspiration to build something which is lightweight and also goes at lower speed. So even in the worst case scenario, if there is a crash or something that happens, it's not catastrophic. And we drive like a bicyclist on the right side of the road. And we move around obstacles, but it's not as complex as driving on the main road, meaning like in the middle of the road. So it's a slightly simpler problem. So it's a bit easier to achieve product market fit. And one key difference that we have in our technology is that most of these companies like Waymo and Aurora and things like that, they use a lot of real world data for training their ML models. So given we are a startup, we wanted to take a more capital efficient approach. And one of our advisors is Professor Jeff Hinton, who won the Nobel Prize in last year in machine learning and physics. So one of the things he said during one interaction was that, let's say a flight is you're a pilot, and then a flight is going, and then there is a sudden engine failure in the flight. And if the pilot has to learn what to do in such scenarios, there's no way they can do it in a real world. So for them to learn what to do in such scenarios, you have to use a simulator to figure out how to learn what to do in such very hard scenarios. So we took inspiration from what he said, and a lot of our training is in simulations. So it's very inexpensive. So you can create a lot of hard scenarios in a very low cost, like at a few cents per mile. We can do that compared to Waymo or other people who use a lot of data from the real world, which requires a lot of capital to generate. So that's one very big difference that we have. And we think that makes the system more safe because you are able to simulate a lot of corner cases and come up with an algorithm which has more intelligence to deal with. So like, a tree falling on the path or a bicyclist suddenly appearing in your way or things like that, which would be hard to do. So that's what we basically do in our company.
Right. Yeah. Thanks, Mahesh. That's an interesting point you raise. And in fact, not in the transportation area, but I've seen how synthetic data and such simulated data is being used in other industries. I mean, one is also lowering the cost of developing the solutions.
Yes.
Secondly, I've seen in the case of NVIDIA Omniverse and how they are using the Omniverse to do such simulations in the industrial setting and so on. So maybe if you can just what kind of platforms do you use to develop these scenarios?
Yes. So in the case of Omniverse, one of the main challenges with robotics is, with large language models now like ChatGPT and things like that, internet is full of training data. So you can easily use that to train the model. But in robotics, that training data is not present, and it's a chicken and egg problem. So basically, there are no robots, so data is not available. And because data is not available, you cannot train robots. So it's like a vicious circle that you have. So Omniverse provides a great platform to come up with all of these data sets needed to train humanoids or any new robots that you want to, train. So what we do is we have built some custom simulators which can predict or which can procedurally generate a lot of variations in the world. Like for example, width of the bike lane, buildings around it, trees around it, pedestrians, cars, hard scenarios. So we create a lot of these scenarios within an hour, which would typically take years to gather in the real world because all of these corner cases happen at a very high frequency in simulation, whereas in the real world, it would take for a long time before you hit a corner case, right? So that is how I think simulated data is being very useful. Basically, the frequency of creating hard scenarios is very high. So learning becomes much faster. And in scenarios where real data is not available, which is true for most robotics applications, it helps a lot. So Omniverse is definitely one platform. We also have used Carla, which is an open source simulator. Mujoku is another one. So there are various platforms that are available today, and people are figuring it out that the realness of the simulator is not the important thing, but the variations that the simulation creates is the more important thing. Yeah.
Right. Thank you. So let's I'll move next to Professor Geeta Krishnan, because I know that he also has done a lot of work in transportation engineering and intelligent mobility and so on. So Professor, if you can talk a little bit about your work and
Thanks a lot. Right. Talking about these variations, right, that Mahesh, I just had a quick comment there and then maybe I'll continue, right? So right now on campus, you have 20 kilometers per hour as a speed limit, right? In fact, the cyclists are faster than the motorized vehicle today. I keep getting overtaken by cyclists, because I follow the rules strictly, right? So I was just telling, Ramki, while you were coming to the auditorium today morning, that the deers have actually become bolder, right? Because vehicles are so slow, they know that they're not going to get hit. So earlier, the deer were more circumspect about coming onto the road, right? Now they are on the road everywhere, right? So basically what I'm saying is, what you train on, you start behaving based on what you train on, right? So if you're going to train on something with a lot of, variations that is going to throw extreme situations, then your robo is going to actually be overcautious about how it's going to move around, right? So I think we really need, the debate is ongoing. I'm not saying we have an answer, right? It's an ongoing debate. I think Srini Parthasadi, he gave a very important point about keeping things realistic, right? We shouldn't accelerate. We need to test sufficiently before we roll out, right? So that's just, I think every point raised so far, I have been taking notes. It's really fascinating. There are a lot of things to talk about. But I'll just come back to some of the AI use cases we've been working on, right? I think our friend from UPS, Dr. Subramani, he mentioned how they had maps before Google, right? And in fact, about 15 years back, CDAC and IIT Madras developed advanced traveler information system solution for Chennai, right? So this was before Google Maps started providing travel time estimates, right, in Chennai, right? And so we started using what we call statistical models, but now, of course, we call them machine learning models and AI models now, right? But we started using those models way back, about 15 years back. We started collecting our own data. We had about 250, 300 buses fitted with GPS devices. All of that was streaming into our lab, right? We had cameras which were streaming live feed into our lab, and we're using all of this information to predict traffic situation, traffic congestion, and give that feedback, right? So that's where we started out, and we've been constantly improvising and revising these models. And more recently, we've been able to use the true machine learning models, not just the old statistical models that are also called machine learning, but the more recent machine learning models, that have been creating a lot of waves now. And we found we are able to get much more accurate predictions, right, when we use these more advanced models with a lot more data, right? So there was a clear shift, right? And this shift also we observed in computer vision, right? So when I came back and joined as a faculty here, there was hardly any data available. And we realized we need to set up sensors, collect data. And I personally started working on how can I use computer vision to collect some of this data, right? Though that was not a field I was working on, I had to take it up because there was a necessity. And again, we hit a plateau. Indian traffic is perhaps the most complex, right? To be able to detect in the dense traffic with all those different types of vehicles, very, very challenging, right? And about 7-8 years back, we started using deep learning models for that. And later today, I'll show you some of the results from what we have done. And it's just amazing, right? On a signal like Nandanam here in Chennai, where you literally have, 3 lanes is how it's marked, but you actually have 7 lanes there, right? So in the 3-lane space, and you have, like a swarm of bees, you have these vehicles which have suddenly discharged and they come at you, and every single vehicle is picked, right, using these deep learning models. I mean, when I first saw that, it was wow, right? We've been working on this for 7-8 years. We were not able to do it, and then we got this deep learning model. We trained it, and I didn't have to put a lot of thought into the training, right? It was all automated, and then I have this really fantastic result, right? So now what all of this is enabled is very accurate data, and we are able to build more accurate models. So we're now able to use it for safety applications. We're able to detect things like wrong way driving. We're able to detect speeding, rash driving, right? All of these violations, and we're able to flag in real time. So I feel all of these will have huge implications, right? In a country like India with so much of vehicle population, human population, we can't have police everywhere. We need these eyes, which are enforcing in an automated way. And I can see, those people who are saying we need longer time scale. I can see within 6 months to a year where behavior will change. Right? Once people know they're being watched, behaviors will start changing, right? So that's something that, another example that is very fascinating. A third example, work we've been doing with the Tamil Nadu Health Service project, right, who are in charge of the emergency services in Tamil Nadu, in terms of where you locate ambulance, how do you react to calls, right? So we collaborated with Lavanya Marla, who's at UAUC, and she has developed our own simulation models to optimize this. And what we did was we added one more layer on top of it to predict where calls will come from. Again, we used some deep learning models to do that, and suddenly we find the accuracy is improved, right? And earlier, in about 4 or 5 districts with a week's data, where we were missing about 200, 250 calls, we were able to attend to another 70, 80 additional calls with this optimized model, right? So that's perhaps another maybe even 10, 15 lives saved, right? So there are a lot of examples where we've been able to use these AI models, improve the results, and some of it is really remarkable. And I think now we need to take it to practice, apply it, and see the change in the real world, right? And of course, we need to have the feedback loop to constantly reevaluate, right? You don't want to make things so safe that the deer thinks, it's the boss of the road, right? So that's something that we need to constantly learn. But it's really exciting what's happening. The results we've seen is very exciting. Yeah. Back to you, Krishna.
Thanks. I mean, very interesting use cases you laid out. I just want to pick on one of them and wanted to get a sense. That is the wrong way driving and speed driving, etc. that the systems now identify. My sense is these would be sort of AI systems in the loop of some human processes. I mean, finally, there will be some traffic people who will use these things. So I just want to understand. I mean, one is post facto using this, and then, I mean, I know, for example, in Bangalore, we keep getting these bills. Suddenly, you will find at the end of the month, you will find one bill, and sometimes it gets the number wrong. And so there is a way now you can go back and protest saying, no, that's not my car at all, and stuff like that, right? It's post facto. It's not really happening. There's not a more real time. So I just wanted your sense. Is there a way, is there a scenario where you can see this as AI in the loop of human and humans in the loop of AI systems, like working and helping safety?
Yeah, so I think, again, that goes back to yesterday's point that we have to be careful while rolling these out, right? So maybe making it completely automated will definitely have its challenges. So we'll need to have maybe a human in the loop, perhaps a traffic constable. Earlier he used to be on the road, but now he could be in the convenience of an air-conditioned control room where he could do a few of these checks, right? And the amazing thing is the AI can learn from the checks that's being made, right? So it'll just accelerate the overall process, and there will be a time when the AI will be ready, right? But I think, we always talk about the type 1 and type 2 errors, right? There is also a cost to the type 1 error and the type 2 error, right? So maybe, if you're trying to make it very accurate with respect to reducing the type 1 error, maybe the type 2 error, goes up, right? So the cost of that could be very high. So I think we need to understand those trade-offs. So in the context of safety, what I'm saying is, yeah, the AI system may get things wrong, but then the discipline it brings and the number of lives it will save is perhaps far outweighs the inconvenience it causes to a few people to protest against a wrong challan issued, right? So these are the trade-offs that I think, we'll have to keep in mind as we roll out these AI systems. And this requires, of course, a broader dialogue, participation of policy experts, social experts as well, right? So we need people from social science to also weigh in on some of these, ideas and thoughts. So yeah, we need a human in the loop, but eventually the human will make the AI better.
Right. Thank you. So let me now move to Naveen Chopra. Of course, Naveen is a very good friend in, along with Professor Venkat Ramaswamy. I mean, my book is coming out. Naveen is featured in that book. We have written about some of the work at Mahindra, and I learned today that he's actually moved to Sun Mobility. So it's good. It's good. Good information that I get through through this event. So welcome, Naveen. Can you just share a little bit, maybe from Sun, maybe in the context of Mahindra, some of the work you have done with AI and safety?
Sorry, Krishna, I couldn't inform you. I just joined this week only, so I was about to write before that this event came and you got to know. I'll connect with you. So I'm in Bangalore only right now. Okay, so I have about 35 years experience in the field of automobile. Started with Eicher trucks and then worked with Honda cars, then again Tata trucks. And then I had a stint with Mahindra for almost 20 years, where I initially worked for about 15 years with passenger car division, and I was the project head for launching Mahindra Thar and the Mahindra Scorpio N, which we are seeing on the roads. And in the last 4 years, I had an assignment with Mahindra Trucks and Bus again. So all through 35 years in automotive, and this week only I've joined in Sun Mobility. Now, after all these 35 years, I thought of now getting into technology, so working on battery manufacturing and battery swapping, and then trying to use more of AI as a part of the heart of the vehicle rather than on the vehicle, which we have been doing. So as a part of my earlier thing, like I started working on electric cars in the year about 2010 or so, where we developed e-Barito as the first electric vehicle in the country. So that was the first electric thing. Of course, at that point of time, AI was not in the mind. It was more of electric. But if I see the change today, the way we have developed, and I've been working for the last 4 years in the bus division and truck division, lot of electric commercial vehicles we are working on. And the same thing I'm now trying to work on in the battery swapping for commercial vehicle. So these are the things which are now taking on. So now focusing on the AI concept, if we see, so AI is, I think, more about what I'll start with Mr. Gopal. What he rightly said, that there are so many gaps which are there in the automotive, that a person in the automotive is safer, but person outside the automotive is unsafe, pedestrian or the other ecosystem support. But that's one part. But if you see the way things have been working in the last, especially 5 years, we have come a long way out. It's now purely how we are using AI to improve the safety of the ecosystem. Because car safety is almost defined now. We all know there are star ratings, which are 5-star, 4-star, very clearly defined. We have even started the driver ratings also. So that's one answer to the query which you put in, that how do we assess. So driver rating system has also been started, though it's not formally linked with many systems. But that's also with the help of AI, things have been recorded. Then we also have a rating system for the roads and all, that what kind of roads are there. And definitely there is a package which is linked to insurances, that how this particular vehicle has behaved or driven. So those activities have also been initiated as a part of our future initiative. And finally, coming to the connected vehicles, a lot of work has been done both in the passenger vehicle segment and I'll say more in the commercial vehicle segment about the connected car. The passenger vehicle, it is more about connected from experience point of view, but a commercial vehicle, it is more about the actual usage point of view, where freight optimization, road load conditions, or the, like for now, the electric swapping station or electric charging stations, even the fuel thing, or the actual load which is available across. So lot of things I can tell you, there's a huge list. So whatever thing I think Mr. Gopal has in mind, we have answers which we are working on. Of course, we are yet to see the day and the light where the real things are happening on the floor. But most of the things we have kicked off. So going for, and all this is now AI controlled. Like this is, I'm from an automotive background, but I can't work without AI. So if I say what is AI, for me AI is implementing all these things. So what I would like to now request the forum and especially Mr. Ramki is that the way Geeta is doing one project along with the team member on the floor, that's my personal opinion that we should have more teams by taking all these individual vertical pillars, which I have just stated, which Mr. Gopal also initially said, and then followed by Mahesh also that he stated, that these are the things or these are the concerns which are on the floor. But there are already ideas available, there are already packages available, data is available. But if we don't do actually on ground execution, what we say maybe in earlier my age or Krishnan your age we were doing, practice makes a man perfect. So what we are doing, we are not practicing AI. Let me make that statement as a senior person. We are not practicing AI. We are talking of AI and we are trying to build more AI. But whatever AI or automated or intelligence or automated data system is available, we are not utilizing it. So first time I have seen Geeta and his team, the way they are on the ground, they are sitting at the airports, they are sitting at the campus stations, or they are sitting at various areas and collecting data and refurbishing the data and relearning. That will make the things more perfect and executable, and that will answer Mr. Gopal's worries that how do we all are safe by using these AIs, either intelligence or database. So that's my core, that execution to the core and practicing it, what is in hand today. At least next 10 to 20 years, we will be having enough work to do. Because there are so many ideas we are keeping building up, but I can say even in my way of operation in the last 5 years, this is my learning, that I kept working on AI things, but I lost my control on what I have developed maybe 5 years back. The utilization is not more than 10, 20, 50, 30, 40%. Then what's the use? If I am, see, today with Mahindra Trucks and Bus, we have launched this connected system about 4 years back. We have tons of data. So, but when we are not utilizing, we are monitoring, we are observing, we have gone to a predictive maintenance. Now it is about even 15 to 20 days before I can tell a customer what is the problem going to be in your vehicle. We have reached that stage. It's a very good stage. But if you feel it's a good stage, I feel there are a lot of things to be done, because this is maybe by 30-40% of the data usage. Still there is 50% of data which can be used by many other ecosystem players, not only by Mahindra. So how do we collaborate? How do we co-create? Now, Krishnan, we come there, maybe with Professor, that how do we co-create with the entire system to use data of each other to create one more global AI, which is not Mahindra AI or Sun Mobility or particular AI, but together as an ecosystem, how can we improve the society or the environment? So that's where is my thing to take on. So sorry,
Fantastic.
maybe a little bit longer,
No,
but
Naveen, I think it's a
global perspective on this.
No, it's an excellent point you have raised. Also, I think it's great that in a forum like this we have the opportunity for academia and industry to the willingness or the expression of interest to work together. So we do have data points. So fantastic. And just on that last point about how that the entire ecosystem is coming, in fact, we came across this example in Europe of the automotive ecosystem, data ecosystem called Catena X, and how the Catena X is creating a data ecosystem for different companies to share data, but eventually different kinds of applications that can be leveraged based on this data. So one of which, for example, was around sustainability and carbon footprint and things like that. But safety is another dimension. So thanks, Naveen. let me now invite.
So question is homework for you, yeah. You have to create that. Moderator
Yes.
also has to take that. Sorry.
Yes, yes.
My take is Geeta is our leader and Krishna is our moderator and we are all the players. So please give us job to create that ecosystem. I am summarizing like that. Thank you.
Yeah. Yes. So let me invite Chandru. Chandru, I know, of course, I interact closely with Chandru on other contexts. So it's good to, and I know you come in from various AI, ML models and modeling perspectives. So if you can weigh in from the work that you have done in this space, that'll be fantastic.
So I think, yeah, I will be sharing my screen. I hope, just a second, I think, yeah, let's see if this, is this fine? You guys able to see the screen? I think I will go full screen.
You can see.
Yes, we can see it.
Full screen. Is this full screen now? Yeah. Yeah, thanks. So thanks to Professor Geeta for inviting me to present this work. So this is some of the work that's happening with the FedEx Smart Center for Mobility at IITM. And this is about reinforcement learning for railways. I will just quickly, rush through the slides. So, okay. So again, what's reinforcement learning? So this is a paradigm where you learn by trial and error, right? And the most important thing here is that you don't have immediate rewards. As in the case of supervised learning, right? Like, so you don't actually have right decisions. Nobody's telling you the right decisions. What you have is you have a setup where you can take your decisions and in the end you get a reward, right? So this is something that fits in very much with the mobility or logistics or right these kinds of use cases where you really cannot tell that, oh, in this signal this is what is supposed to be done, right? Or this is the packet that has to have been routed this way, because it's going to be a collective thing. And especially again in the examples such as connected vehicles, right? So you cannot really, nobody is going to tell you that, oh, this particular sort of formation, this is what is the decision that ought to have been taken, right? So what you do is you learn by making these decisions, and then you observe the rewards, and then you learn by trial and error. And reinforcement learning is a very very is a very very apt paradigm, algorithmic paradigm. Right, and then why railways? So it's just a nice ground to set up a rich variety of problems, right? And focus. Get insights into the fundamental difficulties that you would get with mobility as well as logistics, right? Where you can model from one station to an entire network, so you can sort of scale. You can go microscopic, study what's happening at one junction level, and also at at a global level. And you have a lot of open source simulators. I will be talking about one of it. Right, and it has translational impact, meaning in the sense that you can generalize the learnings and spin it off to other domains, right? You can think of if you replace the passengers with packet, you go from mobility to logistics, and then if you replace the junctions with airports and the trains with airplanes, the fundamental learning problem is the same. Of course, the different domains will give different constraints, but then you have evolved a framework where you can pose all these things in a very unified way, and then the learnings from one domain can sort of percolate into the other, right? And then we have a decent amount of access to prior algorithmic solutions in the railways domain. And most importantly, this is something that totally aligns with the other the opinion echoed by other panelists, which is that this is inherently safe. In that, in this problem, what we are only looking at is rerouting and dispatching recommendations, right? You are not going to take total control of the train. The AI is not going to take control of the train. It's not even going to take control of the hard-coded signaling constraints, which says that if there is a train in one section, there has to be a one section gap between the first train and the other train, right? That's also something what the AI is not going to do. All that it is going to give is within the current infrastructure, it will sort of give recommendation to the station master or the dispatcher saying that this is the train that has to be given first priority, and this is the train that you can sort of attend later. Right, I will come to a very, very even simple, thoroughly safe use case, but it's a very, very interesting use case. So a little bit about the open source railway designer, right? So this is by the French consortium, right? So they have sort of a huge vision that they will get all the entire European, the railway network in this platform. Right. What currently they are only looking at capacity planning. I mean, ability to add infrastructure, ability to add, in terms of rolling stock as well as junctions, as well as tracks, signals, and so on and so forth. Right. But they are not at thinking at the scale of, reinforcement learning. I mean, that's one of the things that they are thinking they will do in the future. And then they have done some pilot, and then we are also starting at that time. Maybe at the level of India, we don't have the ability to create this open source software itself. We will not have the capacity to run it, but then we certainly have the the ability to run and check and develop reinforcement learning solutions based on that. Right. And then you can sort of create these infrastructure, routes, signals, detectors, so on and so forth. And then you can also put in the rolling stock information, such as how much friction is there, what is the speed, so on and so forth, right? And I will sort of tell you why this is all important in one of the specific use cases that we are looking at, right, where things are much more concrete and tangible, right? And you can also add a track information, so on and so forth, right? And then this is the current thing that we are looking at, which is the Chennai Metro, right, where you are looking at only 2 lines, right? And then what happens is that you don't have any, these 2 lines don't talk to each other, so there is no collision that's going to happen over the lines, right? And in a particular line, trains are going to follow, right, one behind the other. And again, as I said, there is only one track that the trains are traveling, as long as you take care of the the junction constraint or the section constraints, right, which can be taken care of hard-coded, there is absolutely no safety issue. Then where is the RL and where is the intelligence coming from? The intelligence is coming from how much do I wait, right? Suppose there is one, so people want to switch lanes, right, because they want to switch lines. So they may be planning a route that requires a switch. And suppose there are 2 trains, and then how do you do the handshake? So suppose I'm a train, I know that there are 50 passengers in this train or in the other line who would want to hop onto this train, right? And then it might make sense for me to wait, right? Sometimes I know that the oncoming train in the other lane is not going to have so many passengers who are going to hop onto my train. So then it makes sense for me to go ahead. So what we are looking at just is waiting policies, right? It's totally safe. It's just you're going to say, do you have to wait extra time? Some sort of a ride sharing is what we are thinking, or some sort of and handshake, right? And that's what we are looking at, and that could be very powerful because you can sort of plan capacity on holidays, on thin days, right? Again, you have rolling stocks. How many coaches, right? How many bogies will each train carry? That depends on the amount of passengers that are there. These are something that you can get absolutely full data on, and all these trains are going to go for a short distance, so all the friction and the amount of acceleration, deceleration, all this will matter in the delays, right? And okay, so again, we have uploaded it. I mean, we have just sort of played around with the tool, and then we are able to get this on this tool. And of course, thanks to the open source logging of the data, we actually have passenger activity data, who booked what ticket and who is going from where. And then this gives us a lot of insights onto the, the geographical aspect of it, right? Which are all school zones, right? And then which means that there is going to be a lot of incoming traffic during the in the morning, right? Office zones and school zones are going to be sinks, and then in the evening they are going to be stores, right? And then you can sort of study this. Should I plan extra trains? Should I, cut a bogie or so? Can I save costs? Can I sort of increase, overall ride experience? These are the kind of questions which you will be able to answer with this sort of a framework, right? And then again, inherently safety is built in. It's very similar to what Mahesh was mentioning, that, okay, it's like a bicycle. Here it's even more safe. It's going to stick to the track, and then it's going to respect the section constraints. So this is again some data that we hope to put, integrate into this simulator in the future. And that's all that I had.
Thank you, Chandru. It's fascinating to see that this kind of work is happening with the metro here. As long as it, just as a passenger, I just want to say that as long as it doesn't mean that I have to wait for some more time to ensure that, like if it should work like clockwork for me. But
Yes.
That's a matter for another discussion.
The hope is that what you will lose in one junction is something that you will be gaining in the other junction, and then the overall experience is going to be smooth. Yeah.
Okay. Okay. Great. So I'm looking at the time. We are at 1:30. Geeta, I think we stop here.
Yeah. I mean, there's just one more session after this, so we can go 5 minutes.
That's
over.
right. I think we should stop. So fantastic. I mean, for me, this was a fascinating discussion. Lots of interesting learnings for me. But the one thing which I'll just close with this was to understand that in India, 3 lanes is actually 7 lanes. And DL models are actually figuring out how to understand them and create solutions. So it's, so I think for all the AI modelers out there on autonomous vehicles, I think if you can come and solve the problem in India, I think you've solved it anywhere else. But thank you everyone for fantastic thoughts and session. Back to you, Geeta.
Yeah. Thank you. Very interesting insights. As you say, we got to hear a lot about the context of the very different regions here, Chennai more specifically. So thank you all the panelists for what you've shared. And can I request Professor Geeta to hand over a memento to Mr. Gopal Ram? Please come forward. And I request the panelists to please, Dr. Ramki, please come onto the stage as well. I request the panelists to please remain online so that we can take a group photo. Yeah, the group photo. Thank you, everyone. And on behalf of MInT Collaborative, I thank all of you for accepting the invitation and coming both online and offline and presenting your insights. With this, we come to the last project showcase, which will be the bus signal priority project. And as Professor said, it's a very interesting project. It's on traffic management strategy that improves the movement of buses by giving preference to buses at signalized intersections to encourage reliability and a model shift from private vehicles to public transport.
Yeah, thank you so much. I think Naveen mentioned this, that he's happy to see us sitting on the roadside and getting the work done, right? So a lot of sitting on the roadside is by our staff and students, right? Many of them are here, and because this is in real world conditions and it's in heavily traffic roads, they have to do this at night. Right, so basically, it's a lot of sitting on the road, getting things done on the road during the night time, right? And the credit completely goes to our project team, our field team, who've been doing this, right? So some of them are here, and so this project is actually based on a project funded by Ministry of Electronics and Information Technology under Intrans program, phase 2, right? And this was developed in partnership with CDAC Trivandrum. And my colleagues, Professor Lalitha and Professor Bhargava, were instrumental in developing this bus signal priority algorithm, right? So I'm just presenting this on their behalf today. So the objective here, as Dr. Kalita already mentioned, was to be able to demonstrate how bus signal priority can be rolled out so that you could reduce the delays that buses face. And nothing is more powerful than to see a bus zip past you while you're stuck in traffic in a car, right? So when you see the buses are overtaking you, it has an impact, right? Then you start thinking, oh, maybe I should also shift to the bus, right? Why am I sitting in this car, stressing myself out, driving in this congested traffic? and I could just shift to the bus and I could reach my destination earlier, right? So that's a kind of powerful visual we want to create, right, eventually. So we picked GST Road, right, and GST Road or Anna Salai is the lifeline of Chennai, right? It's perhaps the most trafficked road in Chennai, right? And so I think, they wanted to give us a really tough test bed, right? The police and the MTC, they said, why don't you do it in GST Road, right? And we said, okay, we'll take up the challenge, and we took 3 junctions. This is close to the airport, right? As you drive towards the airport, the 3 junctions with signals, that's what we focused on here. So the project itself has data that's coming in real time. We'll talk about different sensors. We also have the signal data that's coming in, and then we have a priority request selection module, what kind of priority we adopt, and then we predict when the buses will actually reach the stop line of the signal, right? So you have to time it to perfection, right? You can't, stop the red just 2 seconds before the bus reaches the stop line, right? Then the bus has to wait for a whole cycle. So we need to predict exactly when the bus is going to reach the stop line so that you allow it to pass through. So that's something that we do. Then the transit signal priority strategy selection, there are different strategies we could use. Interestingly, we adopt a very flexible model here. You could give 100% priority to buses, or you could give 0%, or you could have anywhere in between, right? So it's like a knob which you can turn and keep the priority at a certain level. That's something that we've implemented, right? And of course, implementation of all of this in an integrated way. So there is different kind of data that you can get, right? You can get point data, but typically these are more expensive, right? The probe data is good, but then the sample size has been a problem in the past. You also need to detect the buses. So here we actually use GPS devices to detect buses, but then these are high fidelity GPS devices that send data every second, right? So earlier data used to come every 10 seconds, 15 seconds, but here we made sure we get data every second from these buses, right? And again, DOT, Mr. Asit Karayan was talking about how communication, is required for all this, right? So today, with the kind of 5G network coverage we have, getting this 1 second data is possible. 10 years back when we were implementing it, we couldn't get this kind of resolution, but now it's possible, right? And of course, the signal as well, that is a signal controller that's indigenously developed by CDAC Trivandrum, right? Which is something that's used in this project to dynamically change the cycle time as well as the green times. So the priority request selection module has, right, these orders in which priority is given, right? We have to honor FIFO, first in, first out. We have to look at the bus passenger occupancy, right? So typically signals are optimized for vehicles. Depending on how many vehicles are in different approaches, you change the signal timing. But here what we do is we look at how many people are in those vehicles, right? So this is much more people driven. If a bus has 40, 50 people, if one bus is delayed by say 10 seconds, that's actually 500 seconds of delay, right, for all the people in the bus, right? If a car is delayed for even 50 seconds, there's just one person in it, there's just 50 seconds delay. So we look at optimizing overall person delay, right? And we look at headway difference between preceding, succeeding buses, right? We've all faced bus bunching. So you don't want to necessarily keep giving green and encourage bus bunching, but if you have some data on that, you could also phase out things better, right? And also compute the delay of these vehicles, right? So all of these are computed. Then the arrival time prediction basically detects where the bus is, right? It looks at what is the queue length. It estimates the queue length at each approach, right? And then it calculates what will be the time of discharge for this queue and predicts when this bus will reach the stop line, right? And again, all of these are done using a combination of first principles modeling, physical models as well as data-driven models, right? And we also need to keep in mind the phasing, what is happening currently with the signal phasing, right? All of this has to work in real time. Okay, that's a challenge, right? So which we look at. We also need to know what is the speed at which these vehicles are traveling, right? So then of course the transit signal priority strategy, right? There are ideas like green extension where the signal is going to turn red, but you allow it to continue the green for some time so that the vehicle can pass through, right? Red truncation. So there is a particular red in our approach. A bus has arrived. The red was to end 10 seconds later, but I end it right now so that I can let the bus pass through, right? That's red truncation. Then you may also skip a phase, right? If there is not many vehicles waiting on a particular approach, you say, let me not give them green yet, right? Let them wait for one more cycle. I'll give priority to the buses, right? So these can be rule-based, model-based, we have different options there. There are different optimization strategies that we can adopt, and objective function could also be, minimizing vehicle delay, minimizing person delay, doing a weighted objective function of both of these put together, right? Any of the combinations possible. So then, of course, we implement it, right? We adjust the signal timings in real time, we communicate it, and we also make sure that the bus has left the intersection before we turn it back on, right? And we are talking about, only few seconds of margins of error, if any, right? So we all have waited at signals. Even if for 5 seconds, if we find green is priority to an approach, but there are no vehicles, we get impatient, right? We start honking, we start skipping so we need to make it all work, perfectly. So this is a stretch that we've adopted. It's about 4 kilometers long. In terms of travel time, these 4 kilometers you should be able to cover in maybe 3 to 4 minutes during off-peak hours. But during peak period, it can take as much as 15 to 20 minutes, right? So it's like 4 to 5x more delay that happens, right? So this is basically, we have cameras and edge device which is installed, right? We need to have a pole on which to install with 24-hour power supply, right? We've customized these poles to implement it. These are the locations where we have these cameras and edge devices installed, right? If you go to the field, you'll be able to see them, spot them, right? You can see this is at a place called the Post Office Road, and I'm not sure, the cursor is not visible, but basically just below that curve on the signal arm, you can see that black dot, that's a camera, right? And this other camera which is put on a street light, right? So we just used existing infrastructure to mount these, right? And these are fairly normal CCTV cameras, right? So about 2 megapixel to 4 megapixel resolution, right? So that's the camera on the edge device. We're getting data from that. I'll show some videos also of how that works. Then we have these GPS devices in about 165 buses that pass through this stretch through which we get real-time data, right? And again, these buses are all in different depots, right? And to install these devices, again, you have to go during night time, right? So, and these buses, if you go to these depots, they're all packed like sardines inside the depot, right? In fact, to squeeze through that, you have to be a fit person to squeeze through the gaps between those buses and then get to the, place to, install. So, and while you're installing, there will be 100 mosquitoes, that bay for your blood. Okay, so very tough situation in which these were done, right? And, we always appreciate our field staff who do this work for all of us, right? And then the signal controllers themselves, right, installed, to proper specifications, right? So I think we have some videos. So essentially, this is just showing how the GPS raw data is hitting us, right? So it may look like static, but actually, these are all data coming at every second, right? You imagine 165 buses. When we used to get data every 15 seconds, that used to be about 10, 12 lakhs of data every day, right? So this is, we are talking about a crore of data points, right? That is coming in, every day from these devices. So, this is big data problem, not a big data problem like what Pravesh was saying, right? Now we're dealing with really huge data sets over here, right? So this is another video which shows how these buses are getting tracked in real time. So you can see, you can visualize all of these in real time, and you can see they're all getting updated, every second, right? And this is one particular bus. You can see the trajectory of the bus, it keeps getting updated on a second by second basis, right? So, a lot of data continuously getting generated, right? And it's important we get all of this correct in real time. So this is another video that shows how we get the vehicle counts, right? Again, you have the date, time, and then different types of vehicles like auto, bus, car, bike, truck, and so on, right? So this doesn't look that sexy, but then when I show you the video of how this thing works, right, you will see what I'd been talking about, right? So it's really amazing, right? So it just picks about every single vehicle, right? Even the one that's going in the opposite direction, it's able to pick. And the amazing thing is all of this is happening in real time in the field, right? So you can see there's not a single vehicle that gets missed, right? So even this car that just shows up from the roadside, it gets picked. The bus is picked, and then there'll be vehicles which get occluded by the vehicles in front. Even those things get picked, right? So it's just amazing the kind of accuracies that we are now able to realize with these kind of deep learning systems in the field in real time with fairly normal cameras, right? So we're not talking about a very high-end sophisticated camera here, right? Even with normal cameras, we're able to get very, very accurate kind of data. So then this is basically the controller system itself, right? So those are the locations where we have the controllers, right? And we have an interface by which we can view it, right? So if we pick a particular junction, you'll get to know what is the current status of the signal, whether it is on, whether it is offline, right? Whether it is being manually controlled or is it in an automated phase. What are the different signal facing that you have? And you can see right now which direction is getting a green, right? So all of this is real-time data, right? As it's happening in the field, we get to view this in the lab in real time. And of course, when our algorithm modifies these things, right, we are able to immediately see the modification happening in the field, right? We're able to keep track of all of these things. So the entire system is in place, right? The last month and a half, we were actually fighting with power cuts, right? Then we realized we need to put UPSs in these locations. So we did that. And then when we put UPSs, we realized it's getting hot inside these boxes. Then we had to put a fan for the UPS, right? So all the practical difficulties that we have to face, right? Those are things that we took care. And while we are doing all of these things, occasionally somebody will come in and he'll cut the wire, right? He'll break the lock, steal the router inside the box, right? This we're talking about in GST Road, right? Which is heavy traffic, police presence all the time. Even in this, right? In the middle of the road, people are stealing things, right? So it just amazes me, right? How people do these things, here. So anyway, we have some simulation results to show, right? So we simulate all of this with the data we've collected from the field, right? And then we observe how the whole system works, right? So you can see different types of vehicles are represented in different colors there, right? So now we use our algorithm to optimize the signal flow, and yeah. So eventually we are able to collect data on what kind of delays are happening at these junctions, right? So there's a bit of jump here, lag, but yeah, essentially these are the kind of results that we get, right? So what you see here is on a particular intersection, if you look at different signal cycles, right? One cycle is every approach gets a green, right? We come back, that is one cycle, right? So if you look at different cycles, the delays of buses you can see have reduced in different cycles. That's the first part of the table. That's called bus delay, right? And you can see it's as high as, in one case, even 93% change in terms of bus delay, right? And the least is about 22. Certain signal cycles you don't have. Maybe there are no buses, right, there, or the buses were there. They were having anyway minimal delay there. It just continued, right? So while the bus delay is reduced in multiple, double-digit percentages, you can see the percentage change for the other vehicles has not increased much, right? So yes, if you take specific approaches, there may be slight increase in delay, but if you take the overall intersection, right, the delays for others are also very minimal, right? So this is a classic example of how we can tune the system such that the buses get maximum benefit without hurting others, all right? So, yeah, we talk about selfish behavior versus system optimal behavior, right? So while the buses are getting benefited a bit of selfish behavior with respect to the bus optimization, but it's not necessarily coming at a huge cost for the rest of the vehicles. So this system will most likely go into trial this coming week, and once the trial is successful, it will be launched for public use, right, by some of the dignitaries of the state and maybe even the center. They'll come and they will launch this, right? So this is expected to go live this month. Yeah. Thank you so much. Thank you for the time.
Thank you.
I think, we've not given opportunity for the audience to ask questions, so can we? 2 minutes.
Sure. Any questions?
I mean, either in person or online. I think Kush has a question.
Hello. So, thank you first of all for presenting your whole technology. I just want to ask a small technical question. How have you solved the streaming problem in India's unstable internet?
Streaming problem.
Yeah, video streaming problem.
So I think, we've not had too much of a lag, right? Some of these locations actually have, dongles. Basically, they use 5G, right? Some other places we've actually provide, Air Max Wi-Fi kind of connection. We don't send the entire video to the server. We process things in the field on the edge. Only the data is pushed to the server, right? So the data is just counts. We're only talking about kilobytes of data that gets pushed at every instance. So we're not sending megabytes of video data to the server. It's only the processed data, the counts, which are being pushed to the server. And so far, we have not had much of a trouble with respect to data coming in real time. But even if there are lags, we have, we can use models to fill up, right, the missing data. So till the data again comes back, it updates, right? So that's something that we can do.
Okay, thank you.
Hello, am I audible?
Yeah, Kush.
Yeah. So very nice work. First of all, thank you. My question is more in this progression sense. So right now, for example, we're optimizing for bus. Then there was also an issue about ambulance that we discussed earlier, that we want to also prioritize ambulance. So these are all independent but correlated problems that we'll solve step by step while we are figuring out the mobility issues. But of course, they will also conflict with each other because everything won't happen in synergy, so to say. So we'll reach a global solution one day where it's really nice, but what do you think about the process while reaching there? What would be the difficulties, so to say?
Yeah. So I think, the ambulance priority is more direct, right? Ambulance gets priority, period. Okay, so, there's no question of optimizing for delay and things like that, right? When our ambulance approaches, that gets green.
My question is more in the implementation side. For example, you're solving for bus bunching, some other organization, let's say, is solving for ambulance, but the synergy might lack at a state level, let's say, to...
Yeah. So that's why, right? So if you have ambulance, that gets first priority. If you don't have an ambulance, then this algorithm kicks in, right? If you don't have buses, then you're just optimizing. So the way the algorithm is designed right now, it can work full priority to zero priority. That is a continuous gradation I can change, right? And I could always make it work in full priority when you have an ambulance. When you have a bus, it works at say 40% priority, right? When there are no buses, it's just zero priority. So it works across the spectrum, right? So that way, the model is capable of handling these different situations. So policy, is what the traffic police decide, right? So we work with them, right? We educate them and we tell them, this is perhaps what will work best. Finally, they are the ones who are answerable, right? So whatever we recommend, they should be convinced it works, as it's required to, right? So we work with them and we evolve, but there is no standards or policy that's, documented or coded, right? So, but those are areas I think we can again contribute, right? How do we standardize these things? So that's something that we can contribute to. Thank you. Any other online? No questions online?
Online, any questions?
No. Thanks. Thank you.
Thank you, and we certainly look forward to the implementation of the solution on the roads of Chennai very soon. So the last event is, I think, something that's also exciting and something to look forward to, and I asked Professor Geeta to do the honors.
So we had, the teams yesterday present their ideas in the hackathon that we had organized, right? So last time around, the hackathon was announced during our conclave, right? The MInT Collaborative has two main flagship events, right? So one is the MInT Summit, the other is a conclave. The conclave is more invite-only, closed-door, intense deliberations. The summit is, of course, open to share what we've done and to also discuss what we need to do, all right? So last time we did it in the conclave, it just gave the teams about 6 months' time to realize, right, to get to the solutions. But this time, we realize we need to do it much earlier. Okay, so we are happy to announce the next hackathon for 25-26. So this time around, we'll have the team submit their ideas, and we will go ahead and shortlist them, and we will invite the shortlisted teams to spend some time during the summer at the MInT space here and give them support, right? Both advisory support as well as funding if required, as well as opportunity to interact with the decision makers, the real problems, right? And then the solution will be developed to a certain maturity. During the conclave, we'll have these teams present the ideas, and the teams that get shortlisted, they will have a full 6-month period over which they can refine the ideas and provide the demos in the MInT Summit 2026, right? So that's how we've planned it. So this is the initial poster that we are releasing, right? We are, of course, grateful to PALS who have been a partner with us from the first hackathon that we ran, right? And, because it's a hackathon focusing on mobility and intelligent transportation, we've just coined the term MINT-a-thon, all right? So that's the name of the hackathon itself, right? And we invite all the bright minds. We saw the fantastic ideas yesterday to come and work on ideas. We'll send out email shortly. We'll also give certain themes that we are looking to focus on in this year's MINT-a-thon, right? Over the next month or so, you'll get more details on this. I know some of you are joining online and viewing this, right? So we are very excited to see what you all will create, right, this year. And to the teams that have already done the previous hackathon, we want to continue supporting you and take your ideas to implementation, right? So I think yesterday when Ramki asked, I said this is a year in action, so we want to move some of these to action this year, right? So MINT-a-thon 25 is declared open, and we'll send more details soon. Thank you.
Thank you, and we certainly hope to see tremendous response for MINT-a-thon 2025.
So I think it's been 2 days of amazing deliberations, right? I think the best learning, that I have is there is so much of work already happening, all right? And I think what MINT has perhaps enabled us to bring together these diverse stakeholders on the same platform to share the knowledge, all right? For example, with the Bharat multimodal mobility stack that we are talking about today morning, it's just amazing to see the kind of work that's happened in Delhi, the kind of work Namayatri and Kumta are doing in Chennai, right? And the UK Pact work that is just launched in Thoothukudi, right? I believe even if we are able to bring all of these ideas together on the same platform, right? I think we'll already have a great baseline from which to build on, right? So I think the challenge or the opportunity now is to bring all of these stakeholders together, all right, in a single place, platform, right, repository, make this all available, and then let the ecosystem build further on top of it, all right? And so I think that's a great learning, that I have. The theme of the session itself has been AI in mobility, right? And there is a lot of excitement, hype around AI, right? But I think the expert session yesterday kind of gave us a check, a reality check, if I can call it that, right? So yes, AI is bringing a lot of transformation, but let's not be too premature, right, in rolling things out. Let's not be in a hurry to implement things. There are real lives at stake. Safety is very important, right? So we need to move ahead cautiously, right? So that was another great learning, right, that came out yesterday. So today, I think, with the data and digital twins panel, I think we had a great discussion. Again, amazing to see different organizations across the country working on different aspects. But the key again was the willingness, right, to talk about open data, making data available, right, and also developing things that are more integrated. So what is the data I need for the models I build, right? So it's not independent. It's not like you have a digital twin, you have a data, but they have to go hand in hand, right? So that was another very interesting thought that came in, right? And I think also the value of the data, right? So how do you make this sustainable in a longer sense? So that is something that we have to look at, right? So that was a great takeaway. And of course, the use cases we already saw the diverse set, right? So of course, Gopal initially gave some examples, caution where we need to look at what are the opportunities that are possible, right? Of course, one of the good things about MInT is the active industry participation. If it was a typical academic conference, we're not going to talk about insurance and how are you going to monetize it, how are you going to make people use it, right? But having industry partner with us very closely, it gives us perhaps the best chance to succeed, right? The models we build, the data that we collect, how we put it to use will sustain only if you also think about the business case, the use case around it. So I think that was a great learning. And of course, the wide set of applications we got to witness, that was amazing as well. And of course, I'm grateful to all the founding members, right? So we had the founding member panel yesterday. Ramki says he's a people's manager, right? He brings together people wonderfully, right? Just to reminisce on what happened the last year. I thought it was a very interesting way of celebrating our first anniversary. And the industry, they don't have usually a year's time, but they've been very patient. They usually work on much shorter cycles. So again, we are grateful to them. I think we've built a good base momentum, right? I think now we need to carry forward, implement more of these projects. We have several projects that are already lined up, right? Already Naveen made an appeal that he wants more verticals, right? So I think, we are open. We are open for collaboration. We have more work than people. We have more work than, capacity. So I invite, it's an open call to more collaborators to join us. And it's going to happen. And we are looking forward to signing MOUs with some of the government entities as well, right? Including hopefully Kumta fairly soon, as well as with other ministries in the near term, right? And I think all of this will give us the opportunity to sit together, work together. I can now see already the next 4 or 5 roundtables, which are going to be packed with agenda items focusing on each of these aspects, right? So for all of you who have not been part of the roundtable, right, just write to us. We'll be very happy to include you into the roundtable. These are monthly events that happen typically on the last Thursday of the month, and they are an hour and a half long sessions, but very dense, lot of discussions happen, right? And that gives us an opportunity to evolve. So, lot to look forward to, and I of course would like to also take this opportunity to thank everybody who have been responsible to put this together. So it's just amazing, how even a day before we're not very sure, right? Who's going to be here, how it's going to happen, especially to put together something across multiple continents, right? We have participants from different continents, online, offline, right? And of course, government authorities, industry folks, right? It's really quite an exercise. So we have a fantastic team. I just would like to acknowledge all of them. I would like all of them to come up here as well. What we'll do is we'll take a picture together, right? First with the organizing team. After the, I think Kalita will announce that. But yeah, I know I place on record my thanks to everybody. So we'll have a team photo, and then we'll have a photo with everybody together as well, right? So. I have one application that you should make. Yeah. Okay.
So I see in the audience a lot of students and a lot of energetic folks. At MInT, we actually have a need for a lot of talent, okay? And the types of talent ranges wide, right? Part of it is actually working on transportation solutions. We are also looking for a wide range of IT talent, people who can actually build the tech, right? And this is not a joke. We are going to be part of Digital India. It is going to be eventually it'll be the same scale, if not bigger than what we have with Aadhaar and UPI, right? So it is going to be a place where you're going to be cutting your teeth in that sense, right? So we have opportunities here. So please pass the word on to your, if you yourself are interested, please approach us. But if you have friends who are looking for exciting jobs where they're going to be making history, right? In terms of what is going to shape the digital future, please ask them to contact us, all right? Thank you.
Thanks, Ramki. Over to you, Kalita.
Thank you. It has certainly been a holistic view of academia, industry, and government coming together and enumerating all that has been going on in this space. And it has been truly exciting to hear all of this and be part of this summit. And I'm sure that's true for each one of you who have joined the summit. A quote by Roger Patterson goes thus: "Birds have wings, they can fly where they want, when they want. They have the kind of mobility many people envy." I think with its strong focus on harnessing digital technology, the MInT Collaborative is certainly shaping a future where people from all walks of life can move where they want, when they want. And it is certainly exciting to see all of that happening right here at IIT Madras. So I wish them all the success and best wishes for their future endeavors. And at this point, I want to thank all the participants, both online and offline, for having been part of this groundbreaking summit. I would like to thank all the invited guests, the experts, and the collaborators for having accepted the invitation and joining us here, and for your enthusiastic participation. I would also like to thank the driving forces that has propelled MInT forward this year, Dr. Ramki, CEO of the MInT, and Professor Geeta Krishnan, faculty in charge, and also wish them all success for taking this year into the year of action that they envisage it to be. And as we all know that for any aircraft to move forward, there is a backward push that is needed to propel it. And at this time, I thank the organizing team, which has been the backbone, specifically Richa, Rahul, Lakshmi, please come on stage, Gayatri, and all the students, Geeta Sir students, please come on stage, and every helping hand. So I welcome the organizing team on stage for a pic. Yes. So with this, we conclude the summit. Well done, and thank you, everyone. So can we have all the offline participants join us on stage for a group pic?
Come on to the front. Everybody come.
Up, about, and in front. Can we have the Zoom screen if there's anyone online?
Yes.
Yeah, please come on stage, down, on stage, as well as down. Come. The tall ones on stage, down as well. Yeah, please. Are we able to see the online people as well? Are the online people visible?
Yes.
Should they move? Yes? Okay, great. Yeah, come. Thank you. The summit is closed.